In addition to the IMAX photography that Mission Specialist Kathy Sullivan is setting up on the flight deck of Discovery right now, there are some Earth observations, photo targets that have been suggested to the crew for today. One coming up on the next pass over the Texas Gulf Coast area at about 2 days, 0 hours and 6 minutes, a little less than an hour from now. Due to a substantial amount of heavy rain in the Rio Grande River Valley and Gulf Coast area over the last few days and today, Earth Ops folks are interested in having the crew look for and photograph any effects of the heavy rain and flooding, such as heavy silt loads and deposits in rivers and along the coast. This close-up and personal shot on NASA Select Television is of the end effector at the end of the remote manipulator system. The end effector that did its job very well upon command yesterday in releasing the Hubble Space Telescope. All very quiet here in the flight control room in Houston as Discovery continues to perform extremely well. Absolutely no orbiter systems issues being watched or pursued here in the flight control room today. Flight control teams and crew working to a nominal flight day 3 timeline with some minor revisions. At 1 day, 23 hours and 17 minutes, mission elapsed time. This is Mission Control.
Discovery, we're getting some great TV down here during your maneuver.
Roger, Story.
I know you guys are using the wide-angle lenses once in a while.
And Story, your last was cut out. Say again, please.
I know you're using the wide-angle lenses once in a while.
Roger, we're doing all kinds of stuff, a lot of wide angles included. The racket you heard the last time was Mr. Max.
Terrific.
Houston Discovery.
Go ahead.
Charlie, for the IMAX guys, we did the best we could out of W8 handheld, and the geography in view is a view to the west, looking at Etosha Pan and the Namib.
Okay, couldn't be a better place.
This is Mission Control Houston. We're about 5 minutes away from losing our signal through the tracking and data relay satellite east. Discovery beginning to track out over the Indian Ocean as the continent of Africa begins to fade around the side of the Earth in the distance, and in the foreground of our view, the island country of Madagascar.
Too bad you got clouds over Madagascar. You'd have caught the whole thing.
Okay, we copy that, Story. Houston Discovery.
Go ahead.
Yes, Story, looking ahead over the next hour or so for these Rio Grande ops from the storm yesterday. How's the weather around there today?
We'll get back to you.
Okay, how is it right there in Houston?
It's cloudy in Houston.
Okay, well, we'll take a look anyway.
Discovery, we're 2 minutes from the standard TDRS LOS. Pick you up about 2336.
Okay, we copy, Story.
Discovery, we're back with you, TDRS West. Charlie, I got some Texas weather for you when you're ready, but there's no hurry.
Okay, Houston, standby 1. Okay, Story, we're all listening. Go ahead.
Okay, there are severe thunderstorms over Texas. From a line about 30 west of Corpus Christi to 35 northeast of College Station. It's a line that tops 50,000 feet. I don't think you all have to worry. You'll probably top them this time. There is hail in San Antonio. Tornadoes reported in the vicinity of Kelly Air Force Base. Laughlin and Del Rio's 6,000 broken. Hondo's had 2.5 inches of rain the last hour. Austin has heavy thunderstorms now. So you ought to be able to get some good pictures of very high thunderstorms. I don't know if the clouds will be clear enough to get this silt in the rivers.
Okay, Story, we copy all, and just in case we do get some breaks in the clouds, we're going to set one camera up for IR, and we'll try some of the cloud tops with another camera.
Terrific.
And Houston Discovery.
Go ahead, Lauren.
As your folks probably were tracking, we began the free drift gravity gradient at 1 day 23:39, and I imagine they have the errors and rates when it started.
Thank you, Lauren. And Lauren, G&C likes what you got.
Okay.
This is Hubble Telescope Control, Greenbelt, coming out of that last loss of signal. Operators here at the stock failed to acquire communications with the Hubble Space Telescope, and operators are now checking the systems.
Go ahead, Lauren.
For those scorekeeping this morning who would want to know, we did complete round of the DSOs as scheduled, and we're pretty much set up for some downlink of the ion arc. We'll give you a call when that's all ready to go.
Okay, thanks, Lauren. And we don't have TV all the time today, but there is an opportunity between 2 days, 0 hours, 14 minutes, on up to 37 minutes to get some ion arc TV.
Okay, we copy.
This is Mission Control Houston.
Houston Discovery.
Go ahead, Kathy.
Yeah, Story, as Lauren mentioned to you, we're setting up for the ion arc, and we'll be happy to conduct the bulk of that when you guys do have some TV coverage. One question for you. With the camcorder, we think we also can downlink to you a good picture of the arc itself. We're unsure how much time it takes for you guys to reconfigure on the ground to swap from conventional orbiter TV downlink over to camcorder. And if you can get a hack on that for us, it would help us with our planning.
Okay, we'll work on it.
This is Mission Control Houston. The ion arc experiment referred to by Mission Specialist Kathy Sullivan is a student experiment proposed by Gregory Peterson, who is formerly of Box Elder High School in Brigham City, Utah, currently a senior studying chemistry and biology at Utah State University. His experiment is designed to study the effect of weightlessness on electrical arcs. In a weightless environment, convection currents which affect the behavior of arcs on the ground cannot be created. And in light of that, it's expected that the arc would behave differently. So in essence, the objective is to observe the effects of micro-G on the arc without the effects of convections as well. And it is hoped that some of the results of this experiment could have applications in materials processing in space. Again, we're expecting to have some live downlink coverage of the ion arc activity in the middeck of Discovery. That television now scheduled for 2 days, 0 hours, and 14 minutes.
Discovery. We're getting ready to do heater reconfig to B. Do you have any deltas that should apply?
Get right back with you, Lauren. Lauren, we have no deltas.
Okay, thanks, Story.
Discovery Houston.
Go ahead, Story.
In your GG attitude, Teeters West is going to be off the tail. We're going to hand over to East at about 00 hours and 15 minutes. If we're not in comm a couple minutes after that, we'd like you to force us over to Teeters East. It's an item 14 on the SM display.
Okay, we copy. You should be with us, Teeters East, at 0015. If we don't have you within a couple minutes after that, we'll force East Teeters.
That's affirmed. For the Iron Arc people, the student investigator Gregory Peterson is down here taking things in. You might want to try some IMAX using the internal cassette on the Iron Arc. That's your option.
Okay, Story, we copy that, and hello to Greg. We've got all of his equipment rigged here on the middeck already, and we will either start on time, Story, or wait until you think you'll have KU for television. Which would you prefer?
We'd like to have TV. And the TV time we'll have will be from 14 minutes to 37 minutes.
Okay, Story, I didn't copy the first of those times. Say again.
About 15 minutes to 37 minutes after the hours when we'll have TV, and we'd like you to wait till TV.
Okay, we'll do that.
Thank you.
And Story, one other question. You said in item 14, that'll get us S-band over. Did you want a force on KU band also?
Once we get the S-band, we can do the rest, Lauren.
Okay, we follow you.
This is Hubble Telescope Control Greenbelt with a quick update on
Houston Discovery.
Go ahead, Kathy.
This is Hubble Telescope Control Greenbelt. Quick update on attempts to reacquire communication with HST. We came out of a TDRS here about 25 minutes ago, and when we came out of that TDRS, we did not acquire communications with a telescope, and there's no telemetry coming down or going up to the telescope. Operators here are looking at systems here to see why that might be. The couple of possibilities that they're chasing. There is a standing operations request in for such a contingency. Recent changes to the way the Hubble does business on the multiple axis transponder number 2 requires that it operate in an auto transfer function that's disabled for a good part of the time, and it's possible that in this configuration we would have a communications dropout on the Hubble Space Telescope. So they have a standing procedure that's been in for quite some time to work around this, and they are checking to see if that may be the problem before they attempt to reacquire. It also may be that we're on the high gain antenna right now, and that if we don't acquire the signal, we may temporarily go back to low gain for a short time. Again, the operators are looking into why we may not have communication, and we should have an answer here shortly. We're at MET 2 days and 7 minutes. This is Hubble Telescope Control in Greenbelt.
Back with you, Discovery. Discovery Houston.
Go ahead, Story.
We're going to have to give up TDRS. Hubble needs TDRS, so we're going to be LOS here for about 20 minutes, so we will not be able to take that iron arc TV.
Okay, stand by one.
And we'd like to reschedule that iron arc when we've got TV. If you could hold off on it, we're sorry.
This is Mission Control Houston. Our next television, which had been scheduled to emanate from the Shuttle Discovery just a few minutes from now, has been postponed, as we are going to hand use of the tracking and data relay satellite east over to the telescope operators in Greenbelt, Maryland, to continue to try to gain contact through the high gain antenna of the Hubble Space Telescope. Once again, due to our surrendering the TDRS East satellite link to the stock, our opportunity to bring live shuttle television from Discovery of the ion arc experiment has been postponed.
Discovery, we've got you UHF only through Vandenberg. Discovery, we've got you again, UHF only through Vandenberg. Discovery, we've got you UHF only through Vandenberg. Discovery, we're back with you, UHF only through Vandenberg.
Houston, if you were calling, it was weak and unreadable.
Thanks, for UHF only.
Okay, I hear you that time.
And Houston, we've completed the A-plus redundant component checkout at 001800 MET, and no anomalies noted.
Thank you, Bruce. And before we lost you, did you get our words to hold off on the iron arc? We'll reschedule that for when we have TV.
This is Hubble Telescope Control Greenbelt, at MET 2 days and 25 minutes. A brief explanation about why we didn't get any downlink television from the student experiment on board the orbiter. Stock controllers here needed the time on the TDRS satellite to go through a series of steps to reestablish the high gain antenna link between the stock here and the Hubble. There are several steps that need to happen in order to reestablish that link. And right now we are getting no telemetry from the Hubble Space Telescope at this point. So we are switching antennas, and to do that it takes several incremental steps, and some of that takes time on the TDRS. So we did not get the student downlink television at the scheduled time. Operators here are looking into some of the communication problems here to reacquire telemetry with the HST, and at this point they don't know exactly why we're not getting telemetry, but they are looking into it.
This is Mission Control Houston. At 2 days, 27 minutes, the Space Shuttle Discovery is passing high over the Rio Grande Valley and south central Texas area, just about to cross over the Texas coast. Earlier on this orbit, Capcom Story Musgrave mentioned to pilot Charlie Bolden that there's some severe weather over central Texas, which has been producing some substantial amounts of rain, winds, including some tornado activity, and suggested the crew might have an opportunity to observe and document some of that phenomena during this pass. Our next NASA Select television event is scheduled to be a Space Telescope Operations Control Center change of shift briefing with outgoing Director of Orbital Verification Steve Terry. That is currently scheduled to begin at 8:15 a.m. Central Daylight Time from the Goddard Space Flight Center. And our previously scheduled live downlink on orbit 31 of the Ion Arc experiment has been postponed. We will be looking to reestablish that television event on orbit 33 through the Western TDRS satellite at about 10:36 a.m. Central Time. Again, that TV event originally scheduled to have occurred a few minutes ago was canceled in order to turn the tracking and data relays.
We've got JS-band and UHF through Milo.
Roger, Story. We're coming over just the Texas coastline there. We saw the big storm system that's causing all the problem there in southeast Texas today. Looks pretty extensive. The amazing thing to us here on board is we have a perfect view, high-up-like, of Lake Michigan, and the other Great Lakes are less well-defined, but Lake Michigan is standing right there. It's just like you could look out and touch it.
Thanks, Lord.
Wasn't expecting quite this perspective on it, but got to stop and think about it a little bit, how high we are, I guess.
Yep, you all are way out. We haven't had very good comment here. You did not start the Ion Arc, did you?
I think we may have just had the quote of the day again on board. Being able to see Lake Michigan, and he says, "Oh, geez, that means you can see Kansas."
Well, we kind of knew that one was coming. Before we lost you way back there, we were hoping you did not start the Ion Arc. Would you let us know whether you did or not?
Just an amazing sight on the eastern seaboard from just about the Mississippi on east is fairly clear, some haziness. And you can see the entire eastern coastline here. Lake Erie and Lake Ontario. and all the way up see Long Island.
And Cape Cod.
And you can see well to the north of those places, although there is a beginning of a cloud bank starting for the north. I'm sorry if we're boring you with this commentary, but the view is just so fantastic, we got to tell somebody about it.
You're not boring us at all. Are you reading us, Lauren?
Say again, Story?
Do you read us okay?
I'll read you now.
You're not boring us at all.
You bet.
We thought after a while here, we'd give you the view that we have.
Okay, go ahead.
There's this funny looking screen out there with all these oscillating S-shaped curves on it and a little shuttle going around. It's just passing east of the U.S.
That corresponds real well with where we're at.
Discovery, we're about 2 minutes from Mila LOS. We're going to be LOS here for about 15 minutes until 00. About 0050.
Okay, Story, we copy.
This is Hubble Telescope Control in Greenbelt. We're at MET 2 days and 37 minutes. In a temporary move to reestablish communications with the TDRS because stock here is unable to establish the TDRS services through the Hubble's high gain antenna 1 or 2. There'll be their stock operators here giving commands at this time to return the communications to a direct TDRS link via the low gain antenna at a 500 bit per second rate. And the operators here at the Space Telescope Operations Control Center have acquisition of signal with the telescope. The next television event on NASA Select Television will be a change of shift briefing emanating from the Space Telescope Operations Control Center. That briefing will be with the Director of Orbital Verification coming off of the current shift, DOV Steve Terry. That broadcast will take place at 8:15 Central Daylight Time or 9:15 Eastern Daylight Time.
Discovery, we're back with you through TDRS East.
Roger, Story, we have you loud and clear.
The same.
This is Hubble Telescope Control Greenbelt. We're at MET 2 days and 59 minutes. Operators at the stock here have begun activity number 46, or sequence 46. That's a sequence that will verify that there are no changes that have occurred in the science computer memory banks since launch. It'll survey the flight software for changes. This is a sequence that'll take about 45 minutes. We're about 10 minutes from LOS, so the sequence will be interrupted shortly by an LOS, and operators will continue after they acquire that signal again.
Discovery, we're 2 minutes from a TDRS LOS. Get you back at 1 hour, 20 minutes.
Okay, we'll see you then.
And I got some new TV times for the Ion Arc.
Okay, let me get something to write with. Go ahead.
It'll be 3 hours and 3 minutes to 3 hours and 26 minutes.
Copy 303 to 326, and you'll probably get a playback if that's okay.
Playback will be fine, Discovery.
Okay, thanks a lot. That'll help us out a little bit.
This is Mission Control Houston. We've passed out of range of the tracking and data relay satellite east due to acquire signal again in just about 3 minutes through the western satellite. As Steve Hawley and Story Musgrave were discussing just before losing the signal there, we anticipate some television from the middeck of Discovery in the form of a VTR playback depicting ion arc experiment activities. Again, we expect to see that VTR played to the ground at 10:36 a.m. Central Daylight Time on this upcoming orbit 33 through the tracking and data relay satellite west. All systems aboard Discovery continuing to work very well. Absolutely no orbiter systems issues being discussed or pursued by flight controllers here in Houston. We're pursuing very systematically a nominal flight day 3 timeline. We have been on occasion during the last several orbits handing use of the tracking and data relay satellite system over to the Space Telescope Operations Control Center in Greenbelt in order to give them some time on that satellite system in efforts to configure communications through their high gain antenna aboard the Hubble Space Telescope, which right now leads Discovery on its orbital path by about 42 nautical miles. Again, we'll acquire signal about 1 minute from now through the western satellite, and while we're on that satellite coming up at correction on the following orbit, orbit 32, we'll be expecting some VTR playback television taped on the middeck of Discovery of the ion arc experiment, that coming at about 10:36 a.m. Central Daylight Time. 2 days, 1 hour and 18 minutes into the flight of STS-31. This is Mission Control.
Discovery, we're back with you through Tidris West.
You're loud and clear, Story.
The same. Discovery, Houston.
Go ahead, Houston.
Haven't listened to your report of the view, and you'll be crossing the coast about half an hour from now. IMAX suggests maybe it might be a good film opportunity.
Okay, Story. Say again the last part of that. I heard crossing the coast, and then I missed the rest.
IMAX thinks you may have a good film opportunity crossing the U.S. to look up the West Coast, the Gulf Coast, and the East Coast.
Yeah, you bet. We thought of that when we were describing it to you last time, and I think we're going to try to do that.
Okay, the 40 millimeter may be appropriate. You need to remember to load the external film.
Okay, we copy that, and Charlie says that we've already got the film loaded and ready to go.
Thanks.
This is Hubble Telescope Control in Greenbelt. We're at MET 2 days, 1 hour and 45 minutes. Operators here at the stock are continuing to pursue problem with the high gain antenna, and in the meantime they have gone back and reacquired a signal with the telescope through the low gain antenna and are proceeding with commanding with the low gain antenna. Right now they're in a mode to provide information about the fixed head star tracker mapping input that that was gathered about MET 1 day, 19 hours, and they're putting those parameters into place so that they can begin activity number 44. 44 is the maneuver of the polarity check, and that's where this activity is to verify the V1, V2, and V3 axes of polarity on the HST by performing some small angle maneuvers in each of those vectors, vectors 1, vectors 2, and 3.
This is Mission Control Houston at mission elapsed time 2 days, 1 hour, 54 minutes. Everything very quiet on board Discovery and here in the flight control room as we work systematically through a nominal flight day 3 timeline. In just a few minutes on the half hour, we will very shortly interrupt NASA Select coverage of STS-31 in order to televise the arrival of the STS-35 Astro-1 astronaut crew at the Kennedy Space Center, where they are arriving to participate in their terminal countdown demonstration test. The Astro-1 crew met with news media last Friday to discuss their roles and activities in their upcoming 9-day mission aboard Columbia, which is set for launch in mid-May. A series of briefings regarding astro science and mission overview is scheduled for May 2nd on NASA Select Television. That series of briefings will include a mission overview by Astro Lead Flight Director Gary Cohen beginning at 9 o'clock a.m. Central Time at the Johnson Space Center, followed by a day full of science briefings, and as well as interviews and facility tours at the Marshall Space Flight Center. But today, the Astro-1 astronaut flight crew, consisting of Commander Vance Brand, pilot Guy Gardner, mission specialist Mike Lounge, Jeff Hoffman, Ron Parker, and payload specialist Ron Parise and Sam Durrance, are due to arrive momentarily at the Kennedy Space Center shuttle landing facility in preparation for their terminal countdown demonstration test out at Launch Pad 39A aboard Space Shuttle Columbia.
Houston Discovery.
Go ahead, Discovery.
Okay, Story, I completed the RME memory module changeout, and I can give you the numbers if you want them.
Okay, we'll take them. And we're ready to copy, Steve.
Okay, Story, the memory module was replaced at 2 days, 1 hour, 52 minutes. And the values at that time were millirads 876.46 and rem 1.07.
Thank you.
This is Mission Control Houston. That memory module being replaced on the radiation monitoring equipment is a course of routine, as those memory modules are periodically replaced throughout the course of the flight. Once again, we plan very shortly to interrupt NASA Select coverage of the STS-31 Hubble Space Telescope mission in order to televise live the arrival of the STS-35 astronaut crew at the Kennedy Space Center for the start of their terminal countdown demonstration test.
Discovery, we're sending up message 19B. It's a lithium hydroxide canister management message. And Discovery Houston, we're catching your hot mic once in a while.
Houston Discovery, did you call?
We just called to say we were catching some hot mic intermittently. It's clear now.
Okay. We may have been bumping the mic key looking out the window here. And Houston, you might be cloudy there, but over at the SLF looks pretty good weather, maybe a little scattered clouds. We can make out the runway real well from here.
And can you see STS-31? They just pulled up in the chocks. They're climbing out of their airplane. Give them a wave.
We've been waving at everybody in the country.
Believe me, they've been waving back. The whole eyes of the world have been looking at you over the last couple of days.
Very beautiful view of the Bahamas here also.
I'll bet. We're jealous.
This is Mission Control Houston. That concludes our NASA Select coverage of the arrival of the Astro 1 STS-35 crew at the Kennedy Space Center for their countdown demonstration test. And we'll now resume live coverage of the STS-31 mission. This is Mission Control Houston. We're once again taking live downlink television from the payload bay cameras aboard Discovery. This camera, the wide-angle color camera mounted on the elbow of the remote manipulator system. Discovery currently in a gravity gradient nose towards the Earth payload bay into the velocity vector attitude. This in support of a demonstration of the orbiter's ability to maintain a stable attitude without reaction control system support by using the natural forces of gravity. Discovery now beginning to track out of the Caribbean and into the Atlantic Ocean after having passed through the Gulf of Mexico and looked down upon the Florida Peninsula, including the shuttle landing facility and launch complexes at the Kennedy Space Center. Discovery now on the descending node of orbit 32. All systems aboard Discovery continuing to function flawlessly. There are absolutely no unresolved anomalies, no orbiter system issues being tracked here in the flight control room. We are anticipating some downlink television upcoming on the next orbit, orbit 33, through the Tidris West satellite.
Discovery, we're receiving TV from you now. We're coming up on a non-standard LOS. We'll be gone 2 hours 24 minutes to 2 hours and 32 minutes.
Roger, Houston, we copy.
And did you happen to record on the VTR the high gain deploy yesterday?
Yeah, Story, I'm pretty sure we did. Do you need us to dig that tape out of the return to Houston bag for you?
We sure would appreciate that.
Okay, that's in work, and if you would pass to the IMAX folks, please, that San Francisco and the western U.S. looked great, and we think they will think so too.
Thank you very much.
This is Mission Control Houston in efforts to assist the Space Telescope Operations Control Center folks in troubleshooting their high gain antenna challenges today. Kathy Sullivan was asked by Capcom Story Musgrave to dig out the videotape that was made on board yesterday of the Hubble Space Telescope's high-gain antenna deployment. And hopefully we'll have the opportunity to bring that down to the ground. On Orbit 33, we are anticipating some downlink television from Discovery in the form of a videotape playback of ion arc student experiment activities on board in the middeck of Discovery. We're expecting that downlink at about 10:36 a.m. Central Time this morning. All very quiet here in Houston as we march through a nominal Flight Day 3 timeline at 2 days, 2 hours, and 24 minutes. This is Mission Control. This is Mission Control Houston at mission elapsed time 2 days, 2 hours, and 30 minutes. That's into the flight of Discovery on shuttle mission STS-31 as we rejoin NASA Select viewers with live coverage of shuttle mission STS-31. Flight controllers currently out of direct contact with the crew Discovery as we've handed over the tracking and data relay satellite system for just a few more minutes to the folks at Goddard who are continuing to get a handle on the high gain antenna situation they've been dealing with today.
Discovery, we're back with you.
Loud and clear, Houston.
The same Discovery.
And Story, we do have a tape of the high gain antenna deploy, although we were not recording at the moment the latches were released. So we did not record the initial movement of the boom, but we recorded from the start of the deployment to the completion of the deployment.
Okay, thanks.
And we can send that to you whenever you have coverage.
Next time we can take that is when you're doing the ion experiment. So maybe when you get done with that downlink, we can then get the high gain antenna.
Okay.
That's in the period 3 hours and 3 minutes to 3 hours and 26 minutes.
Roger that.
Discovery Houston.
Go ahead.
Sometime probably in the next 20 minutes or so, you may get a G23 RCS system. That's a right RCS fuel tank temperature. It's due to switching to the B heaters. No action required. We'll go back to the A heaters when you go to sleep.
Okay, copy that. Houston Discovery.
Go ahead, Kathy.
Story for your TV planning purposes today. We have the sort of documentary description of ion arc being accomplished on Orbiter TV. That's recorded on BTR with a voiceover that we did at the time. Then we have some views of the arc itself that we recorded on camcorder, and we can dump both of those down to you. You guys, I guess, need to do some reconfiguring down there to switch over from one to the other. But we have them ready for you, and we'll send them down when you'd like them.
Okay, thank you. The reconfig takes less than a minute. We'll get that at 3 hours, 3 minutes to 3 hours and 26 minutes.
Okay, and you can probably take another minute of greater views while you switch over or something.
Okay, and while we're talking to EV2 here, got some questions for you.
Well, so I figured eventually we'd get around to that.
You got a moment now?
Sure, go ahead, Story.
Were both of you using bus select main A down on airlock AW18H?
That's affirmed.
And during the repress, on that comm check. Was EV1 on comm A and 2 on B?
That's also affirmed.
How close together did the power restart messages occur?
Story, during the couple of minutes that Charlie was moving me from the airlock out to the middeck so he could reposition Bruce, I got 3 of them. So I guess I don't have a very accurate idea of what their spacing was, but it was 3 within a period of certainly less than 5 minutes, possibly less than 2 minutes. And let me offer you this one other observation. I thought about it some overnight. One other power restart while in the airlock at 5 psi that I recall best also occurred as I was moving to my right to see one of the panels. So if there's a correlation there at all, the one I'm wondering about is as the SCU was flexed and moved through various ranges, I got these spontaneous power restarts. While quiescent in the airlock otherwise, I got no other power restarts.
And you do think the SCU was firmly attached, the T-handle over and locked?
Yes, sir. SCU was fully attached. Multiple connector was over center lock. And Story, I might also mention, I looked over at EMU1 input amps during some of the latter period of the 5 psi ops when I was watching my own suit input, and I did not see comparable oscillations on Bruce's EMU input amps. Houston, how copy?
Getting it loud and clear. Could you give us also some more qualitative words on the fan motor boating or fan noises?
Well, for a while I wasn't even sure I was hearing that, but later in the 5 psi ops, I heard what I suspect is the sound we allude to as motorboating, and it sounded as if there were some motor revving up and down in RPMs. Let me think if I can put some better words on that. Well, let me just say this. With a properly operating fan, I think I'm typically only aware of the vent flow air noise in the suit, and there's just a nice steady level to that and no oscillations of note on the noise level. And late in the 5 psi ops, I noticed rather faintly sound that sounded like a distant motor, chainsaw type motor, or motorboat type sound, as if someone was gunning it and revving up its RPMs cyclically. This was not continuous. I heard several periods of it. Mentioned to you yesterday, I think, that I do believe those periods of audible motor-like noise correlated with higher amplitude fluctuations on my suit input. Can't constrain it any better than that. Over.
Okay, that'll do it. Next time you're down near the airlock, you might check your SCU connections to the airlock wall itself.
Okay, I'll do that. Houston Discovery.
Go ahead.
Okay, Story, I just checked the electrical connections on the AW82 panel, both mine and by comparison EV1s, and I see nothing anomalous there.
Okay, thank you, EV2. Discovery for a couple minutes to a Tidris LOS. See you about 3 hours and 3 minutes.
Okay.
This is Mission Control Houston. We're just about 1 minute away from losing signal through the Tracking and Data Relay Satellite East after what was already a fairly quiet pass through the Tracking and Data Relay Satellite System on orbit 32. We'll acquire again about 4.5 minutes later, and when we do, we anticipate some television from the Space Shuttle Discovery in the form of a videotape replay previously recorded on the middeck of Discovery of the student experiment ion arc activities. We expect to see some orbiter camera with voiceover from the crew, followed by some of their high fidelity camcorder video of the ion arc in operation. That's coming up in just about 5 minutes at 10:36 a.m. Central Time.
This is Hubble Telescope Control in Greenbelt. The orbital verification team has completed sequence 44, which was about an hour-long sequence to verify the attitude commanding to the telescope. This was accomplished by sending the telescope commands that performed small angle maneuvers in each direction. Again, that was designed to verify the attitude commanding capability of the telescope. At the present time, the orbital verification team console operators are continuing to, or were until we turned off the multi-axis transmitter prior to going into the zone of exclusion. We're monitoring data from the telescope, which is healthy, and other team members have been studying the difficulties encountered earlier in acquiring the tracking and data relay satellite with the high gain antenna. We have, however, been reestablished for a considerable amount of time with the tracking and data satellite through the low gain antenna system, and we're continuing to study the high gain issue. We turned off the the low gain antenna or transmitter just prior to going to the zone of exclusion, and once we reacquire a signal, we'll reestablish communication, turn on the transmitter again. Our next activity will be adjustment to the release attitude, and this basically maneuvers the telescope such that the door points away from the sun in preparation for fixed head star tracker to rate gyro assembly alignment. This activity is designed to correct any attitude errors that might have been induced in the system when the vehicle was released from the remote manipulator system yesterday. At 1 day, 3 hours, 1 minute, this is Hubble Telescope Control, Greenbelt.
Discovery, we're back with you.
Loud and clear, Story.
The same.
Houston, Discovery.
Go ahead, Kathy.
Yeah, at the risk of belaboring the EMU-2 report more than you guys need, let me just repeat some points I think I made yesterday, but the amplitude, the audible amplitude and the period of these speed or motor-like sound oscillations that I heard, I made an allusion to like a chainsaw, and I didn't want to give you the impression that the period of these oscillations was very short. It was a fairly, maybe a half hertz, something on that order. And their amplitude, again, audibly the amplitude was very low because the whole signal was fairly low in the audible range. But the RPM oscillations up until the last 2 minutes of the 5 PSI ops had never been enough to trip even the 10th bit on the span RPM on the DCM.
Okay, thanks. And we're ready for any TV you've got, VTR or camcorder. Let us know which.
Okay, Story, we're just getting folks through the meal period here. We'll be with you in a minute.
Thank you.
And Story, I think we're going to try to send you the recording of the ion arc experiment, so it'll be orbiter CCTV initially.
Okay, Steve.
Of an electrical arc as you observe it on the ground in 1G, say during a Jacob's ladder experiment in high school. And that is exactly, in fact, the kind of experiment that first gave this idea to Greg. He subsequently attended a lecture at Utah State University about the student experiment program on the space shuttle and zero-G effects on a variety of phenomena. And he put the two observations together, zero-G characteristics and what he had seen in the Jacob's ladder, and conceived of this device to try to get an understanding of whether, in fact, those gravity effects are entering into the Jacob's ladder type behavior. What you see on your right here, taped to the forward lockers, is the arc chamber itself, and the Aeroflex camera is set up to look into the arc. There are mirrors behind the arc so that you get, in fact, three different views of it. The first thing we're going to do here is photograph the arc behavior in the ambient magnetic fields of the orbiter, and we, in fact, will look at three different orientations. The path of the arc, as the experiment is currently placed, goes parallel to the orbiter's y-axis through the wings. We will then rotate the box and camera 90 degrees to look at the orbiter's z-axis, vertical like this, and then again we will rotate it 90 degrees and tape it on the overhead panel so that we can look at the ambient magnetic field parallel to the vehicle's z-axis. In that position, we will leave the experiment taped down and then apply varying internal magnetic field strengths to the arc to look at what their effect is on its shape and behavior. I'm going to go off comm now here, and Charlie and I are going to start making the observations with no applied magnetic field, ambient field parallel to the orbiter's y-axis. And you'll see Charlie ducking in and out of the scene with our camcorder to get concurrent views of the arc, which we then will be able to put on the downlink for you and give you an idea earlier than end of mission of what we have seen with this experiment. By the way, let me mention that Greg has advanced several years since high school and since the conception of this experiment, and he's due to graduate shortly from Utah State University with a dual major in chemistry and biology. So Greg, from the entire STS-31 crew, we hope the data obtained here in flight is an outstanding graduation present for you and maybe spurs you on to even further research.
This is Mission Control Houston. We've just momentarily lost our signal as the KU-band antenna is in the midst of a gimbal flip. When it swings around and reacquires a line of sight pointing, we should acquire the signal again.
Discovery, we are receiving your TV. It's great.
Okay, what we're going to do very quickly now, we hope, is we're going to take the experiment off the bulkhead where it is, just rotate it 90 degrees such that the arc path is now going through the orbiter's z-axis. So what we're going to do is we'll actually rotate it so that the side facing me now becomes the top, and we'll repeat the experiment again with no magnetic field on it. And Story, I understand you are receiving the downlink?
We sure are. It's terrific.
Okay, great.
As we said, ignore the fault messages you're getting now. If they keep coming, we'll go back
to we got that,
B.
Story, and okay, we copied that. Just wanted to explain one thing to you here, because you guys aren't going to see very much more than us just moving the equipment around. What we have, and we'd like to dump to you at some time, is the camcorder, which actually has the arc. Or if you can switch over real quick, we can give you about a minute or two of the arc itself, so you guys can see it, and then we'll dump you the whole thing.
Okay, let us know if you want to do that. Discovery, when you're ready, we're ready for camcorder downlink.
Okay, Story, we're going to give you that once we finish with this little bit here, because Kathy will summarize the final rotation. What we're going to do is we actually have the arc this time will be generated fore and aft or in the orbiter x-axis. Story, I think we're going to swap over to camcorder, and Charlie will show you the ion arc.
Okay.
And Story, I can't remember, do you guys get the voice with this or just the picture?
We're getting the arc down here now.
Okay, but you're not getting any voice, right, from the camcorder?
Not yet.
Okay, you probably won't. And basically what you're seeing here, and we're going to, we'll show you this a little bit. We have actually, as you can tell, turned the power on, and we have actually applied a magnetic field. So we're stepping through the fields. We did not show you the arc with no field applied. So we're going up through 5 different levels of magnetic field. And as you can see here, as we do, it looks like the arc tends to get more and more rambunctious. And the thing that you need to note is that you see what looks like 3 arcs. It's actually only one. The one you should concentrate on is the center. That's the actual arc itself. The others are just reflections. The reason we think you see a very finely defined arc on your right is because that's the tip of a nail. The other part of the arc system is actually the round head of a nail, and we think that the arc is just, or the charge is just kind of jumping around from place to place on the head of the nail, and that's what allows it to go that way. But if you guys can get Greg to come in, he can probably tell you whether we're right or wrong. But we did notice that the behavior of the arc became more and more erratic, and its amplitude increased as the field went up. And just as they had told us pre-flight, once you put a charge into the system, it never comes out of there. So even when we go back to no field at all, we still have the erratic behavior on the arc.
Okay, thank you, Charlie.
And it appears that the amplitude of the arc oscillation is growing with each of these field strengths.
Yeah,
Field strength 2, going to 3 now.
Greg is really appreciating those images. Says it's terrific.
Okay, and hopefully...
Going to 2 now, and the arc still looks randomly...
We're trying to get you to a closeout point here, Story, and we'll be finished.
Okay, and Greg says you had the interpretation just right, Charlie.
Thank Greg Peterson for a good idea.
And Story, if you can give us about 2 minutes here, we'll ask you to reconfigure so that you can get the VTR, and we'll play the close.
That concludes this Operation Student Experiment 8.
And Greg asked if the iron was steady.
Say again, Story?
Greg was asking if the arc was steady when no external field was applied.
When no external field was applied, the arc was still a little bit jumpy, but not anywhere near what you see now.
Okay, thanks.
And, you know, that's why I said, you guys give us a time later on in the day when we can dump the entire camcorder, and I think that'll help him a little bit better because he'll be able to see the arc in that real time, you know, before he gets the film back.
Okay, Charlie.
Okay, we're going to be away from you for about 2 minutes, and we'll come right back when we're ready for the close.
Okay.
And the practical aspect of how it works in that the cavity retains some of the magnetic field once you begin to apply it. So the actual field strength in the cavity now is not as low as it was before we applied the external field. And that concludes.
Okay, Story, are you ready for the VTR again?
We'll reconfigure.
Okay.
Discovery. We're ready for VTR downlink.
Okay, it's coming.
All field. And that concludes this Operation Student Experiment 8216. We certainly enjoyed and learned a number of things from being a part of this, and again would like to thank Greg Peterson for a good idea and a good experiment and congratulate him on a successful flight and wish him all the best in his post-college career.
So long there, Greg. And thank you guys very much, Story.
Hey, Discovery, we enjoyed that. Could you give us, for flight planning purposes, an idea of about how many minutes is on the camcorder to come later?
You guys want to see the high gain deploy now?
Yeah, we can take that now.
Okay, and Story, one more thing about the camcorder. When you're ready for it, we give it to you. The very first 50 seconds or so is going to be a real short presentation on DTO 644, the microbial filter, where we actually will show you the sample that we took and also show you some of the bubbles in the water. Okay, and you wanted to know how much we have on the camcorder?
Yeah, for flight planning purposes.
Okay, let me go back and I'll give that to you real quick. And Houston Discovery?
Go ahead, Charlie.
Yeah, Story, including the DTO, it's 13.5 minutes.
Thank you. And we are getting the high gain antenna deployed downlink.
Roger.
Story, I think that's all of the high gain stuff. And if you got a minute or two left and you want to go back to camcorder, we got that set up on the flight deck, and you can come inside.
Discovery, thank you very much, Steve. We just went into Teeter's blockage. We can't receive any more.
Okay, well, we'll show it to you some other time.
We enjoyed all of that, though. Thank you very much.
You bet.
Discovery Houston.
Go ahead.
Bill Reeves, Orbit 1 team, and myself going to hand over here to your Orbit 2 team, Milt Helflin, Jim Boss. We sure enjoyed working with you. See you tomorrow.
Okay, we enjoyed it too. Thanks very much.
Good day. Nancy Jackson says good day too.
This is Mission Control Houston at 2 days, 3 hours, 41 minutes into the flight of Discovery and STS-31. The Orbit 2 team now has completed their handover from the Orbit 1 team. And with that, our next television event will be a change of shift briefing with the off-going Orbit 1 flight director, Bill Reeves. That briefing is scheduled for 11:30 a.m. Central Daylight Time. That's in about 15 minutes. Again, that briefing upcoming at 11:30 Central Daylight Time.
Discovery Houston, UHF through Vandenberg. How do you hear us? Discovery Houston, UHF through Vandenberg.
Loud and clear, Houston.
Okay, just for information, looks like White Sands lost their computer that runs the TDRS network, so we're going to be UHF through Vandenberg and then Mila, and it could be a little while before they get that back up and running again.
Houston Discovery did not catch your last. Say again, Jim. Okay, I understand. UHF Vandenberg and Mila due to WizKit outage.
That's correct. Discovery Houston, I have an update to your flight plan update. That's message 12, page 3. If you get that out, I'll give you your change. Say again, Discovery.
Yes, sir. Houston Discovery.
Go ahead, Discovery.
Okay, go ahead. We're ready.
Okay, Charlie, we're just getting you fairly weak through Mila UHF. On page 3 of message number 012, at 5 hours, there is a call out on MCC Go to take the rad controller outlet temperature to high. We'd like you to delete that call out. There's no need for the FES dump. And on the next page, page 4 of message 12, at 9 hours and 45 minutes, we'd like for you to delete all of the rad controller and FES controller steps that are from about 9:45 until 10 hours. Over. And we've got about 30 seconds of Mila left, Charlie.
We copy, Jim, and we deleted the item that you were talking about.
Okay, we may see you later when we get TDRS back, or we'll see you when we get the next UHF ground station.
This is Mission Control Houston at 2 days, 4 hours, 14 minutes into the flight of Discovery on STS-31. Back here at the Mission Control Center, flight controllers have just had a local weather briefing on the weather that's moving across West Texas toward the east. The local area is now under a tornado watch, and the ground controller reports that we are in a position to have our diesel generators powered up if the need arises. However, that weather system's moving about 10 miles per hour to the east and is not expected to be real heavy in the Houston area until later this evening. Just a short while ago, the White Sands Ground Terminal reported that their central computer went down, and that occurred about 2 days, 3 hours, 31 minutes. And they reported that that would take about 40 to 45 minutes to bring that computer back online. However, that took less time, and that computer is back online, and we are able to command or take commands with the crew through the tracking and data relay satellite system. So that system is back up and working, and all is back to normal on the TDRS network. We're now at 2 days, 4 hours, 16 minutes mission elapsed time. Discovery now on the descending node of orbit 33, just passing out off the east coast of Brazil. This is Mission Control Houston.
This is Hubble Telescope Control Greenbelt. The orbital verification team here in Maryland continuing to look at the high gain antenna issue. That system, when we attempted to acquire communications with the Hubble telescope through its high gain antennas, we were unable to acquire communication. Meanwhile,
Discovery Houston, we're back with you on the east satellite now.
Roger, Houston, loud and clear.
And Houston Discovery, you really should be up here with us. The view from 330 nautical miles is absolutely spectacular. You can very distinctly see the curvature and the spherical nature of the Earth. We just completed a pass coming out the east coast of Brazil, just south of Salvador, and it's a really spectacular day up here.
Hey, well, thanks for those words, Bruce. If you noticed the weather over Houston as you flew by, we may all wish we were with you.
Roger, Jim. While you were gone, the PPCO2 tripped the limit, and we executed the tags message, and we put 3 in Alpha and 1 back in position Bravo.
Okay, Steve, thanks for the report. We were wondering.
this is Hubble Telescope Control, Greenbelt. During the period of time that the tracking and data relay satellite system was unavailable, the telescope onboard DF-224 systems computer began execution of sequence number 45, which is an adjustment to the release attitude. Basically, it returns the telescope to an attitude similar or very close to that attitude in which it was released, with a minus V1 axis, the tail of the telescope pointed toward the sun. Again, this first part of the sequence is a program that was stored on board the computer and was kicked off by the computer using its internal clock. The beginning of the sequence occurred in the blind, and controllers and the orbital verification team hope that this particular activity may improve our situation with acquiring communications through the high-gain antennas. At the present time, we are receiving telemetry from the telescope through the tracking and data relay satellite system. Everything looking good at this time. All of the subsystems are performing normally, and there is some commanding that is being sent to the telescope to configure some of the systems. Some of it is housekeeping type commands. Meanwhile, the orbital verification team here is continuing to study the high-gain antenna's earlier inability to capture lock on the tracking and data relay satellite. At this time, there is no attempt underway to accomplish or to retry that. At 2 days, 4 hours, 22 minutes mission elapsed time, this is Hubble Telescope Control in Greenbelt.
Houston, Discovery.
Go ahead, Discovery.
Yeah, Jim, thinking ahead to the next IMAX opportunity, which we show per the originally published cap without revision to be a rainforest shot over Amazon. And I guess I have a somewhat question for the IMAX folks. We just had a fairly good pass across the northern third of Brazil. There is a lot of popcorn cumulus scattered across the basin, but still fairly broad open zones along the river courses. The river courses themselves in many places were readily visible. We don't have a good view to our south right now because of our GG attitude, so I really can't say accurately what the next pass stepped over to the west might be. But presuming we find weather similar to what I just described for the upcoming opportunity, I'd just like to know if that's within IMAX's weather tolerance. And I guess my vote would be probably yeah, because I sure have never seen any much less cumulus over the Amazon, but I'd like to know what Tony and them would say.
Okay, Kathy, our payloads officer is nodding his head that that's okay, and we just had a message for you anyway that was going to tell you the weather was favorable there. So we were going to pass that to you as you got a little closer. So it looks like it's okay, and you might be able to get some good shots with IMAX.
Okay, well, it sounds like your data agrees with our empirical data, and we'll press on.
Okay, thanks, though, because we never trust our weather for sure until we get there. So thanks for the report.
You know better than believe a weather guesser.
Discovery Houston, we're going to be LOS in about a minute. We'll be back with you at 4:47.
4:47, see you then.
This is Mission Control Houston. We've lost signal through the tracking and data relay satellite east. We are ready to acquire signal on the western satellite in about 50 seconds.
We're back with you, Discovery.
Okay, Houston, we're here. Houston, Discovery.
Go ahead, Kathy.
Yeah, Jim, continuing on the vein of some of the comments you've heard from all of us over these last few dayside passes, let me just add, I hope you guys are really taking maximum possible advantage of the payload bay TVs here to show the American people and people around the world a view of the Earth like they've never ever seen from the space shuttle before. And we've really had some spectacular passes that show parts of the U.S. you can't typically see from this orbit, and I'd like to share them with as many people as possible.
Yeah, Kathy, and we appreciate any comments you have, too, as your travel log as you go along. Those are always nice to have. Just got a yell from the INCO console down there, reminded me that we were going to remind you tonight to please leave the payload bay cameras in command for us so that we can watch.
Absolutely, and keep an eye around on the night passes also to the southeast of Rio and Sao Paulo, Brazil last night. Charlie and I saw one of the more spectacular displays of airglow that I've ever seen, with a real distinct lower boundary and the expected diffuse upper boundary, and then what appeared to be a vertical extent that we speculate may have marked approximately the South Atlantic anomaly. The night side passes have been every bit as good as the day passes, just a little harder to capture on the TVs. And in fact, I'd give you the bay cameras now if you wanted for some of the night side lightning and stuff that we're seeing in the Indonesian archipelago.
Okay, thanks, but we don't have the KU band on the west satellite this pass. Maybe we can do some of that later on.
Okay, we'll be happy to oblige any time. If we forget, rattle our cage and we'll give you the bay cameras.
Okay, we'll ask for it next time we have some good KU band for it, and take lots of good pictures.
Yeah, we're making our way through the shuttle standard film allocation at a pretty rapid rate.
Sounds good.
This is Hubble Telescope Control Greenbelt. 2 days, 5 hours, 16 minutes mission elapsed time. The orbital verification team here in the Space Telescope Operations Control Center is continuing with orbital verification sequence number 25, which basically is an adjustment to the release attitude. The first part of that sequence was actually executed by the spacecraft's DF-224 subsystems computer automatically at approximately 1620 GMT, and that first portion of the sequence involved commanding the spacecraft to return to its release attitude, basically placing the minus V1 axis or the aft end of the spacecraft toward the sun. Now, that activity occurred during the period of time that the ground system computer at White Sands was down, and therefore it occurred in the blind. Controllers here were unable to see that activity. However, when we reacquired data from the spacecraft after the tracking and data system became operational again, we were able to confirm that, in fact, that first portion of the sequence did execute on board the spacecraft, and the spacecraft did return to the release attitude. The remainder of the sequence involves gathering fixed head star tracker data. This is portion of the sequence is being commanded step by step from the Space Telescope Operations Control Center. This data will be gathered and then analyzed on the ground, and it will be used to provide an attitude reference update, basically updating the Space Telescope's knowledge of specifically where it is. Also, during the last hour, the control team here has been doing some additional housekeeping commanding. This included an update of a load that was sent to the spacecraft. Actually, it was providing the second half of a load for the DF-224 computer, which will enable the computer to continue executing certain procedures automatically based on spacecraft time. Specifically, the load that was uplinked to the computer included high gain and low gain antenna management information. Of course, at the present time, since we're not using the high gain antennas, that information is not required, but once we do reacquire signal or communication with the tracking and data relay satellite through the high gain antennas, this information will be used by the computers to point the high gain antennas. Again, the other portion of the load, which is the low gain antenna management, will be used as we are now communicating with the spacecraft and receiving data from the spacecraft through the low gain antenna system. Meanwhile, the analysts here at the Goddard Space Flight Center in Maryland and analysts at the Huntsville Operations Support Center in Alabama are continuing to study the situation with the high gain antennas. And while we do not have a total resolution on the exact cause for the inability to communicate through the high gain antenna, Director of Orbital Verification has indicated that this attitude reference update may improve that situation. At 2 days, 5 hours, 21 minutes mission elapsed time, this is Hubble Telescope Control, Greenbelt.
And this is Mission Control Houston. Our next shuttle television will be some payload bay views on orbit 34, that upcoming at 12:58 p.m. Central Daylight Time. That's just in a couple of minutes. That would be at a mission elapsed time of 2 days, 5 hours, 24 minutes. And this is Mission Control Houston. We're waiting to hand over from the west satellite to the east satellite, where we'll get some KU coverage and be able to bring down some television from the payload bay of Discovery. This is Mission Control Houston. We're now taking payload bay views from camera A, that's on the forward left bulkhead of Discovery, looking across the bay toward the right side of the vehicle. In the upper right corner is the right-hand payload retention latch assembly, or PERLA, which was used to hold the right side of the Hubble Space Telescope in the payload bay during ascent and during the early part of the mission. That retention latch is in the open position. All of those latches will be closed prior to closing the payload bay doors and coming home on Sunday morning.
Discovery Houston, we had a long hand over there. We're back with you.
Okay, Jim, I copy.
This is Hubble Telescope Control, Greenbelt. 2 days, 5 hours, 37 minutes mission elapsed time. Orbital verification team continuing to step through sequence 45. Presently continuing to take fixed head star tracker data. We have some of that data on the ground, and the analysts have taken a look at it. We have received word that the data looks very good, and that we are preparing to send an attitude reference update to the spacecraft. The data that we're taking now is low gyro mode data. We did take data earlier with the telescope gyros in what we refer to as the high mode. They were in a slightly different configuration. That data was analyzed, and an attitude reference update was sent to the telescope. However, the data that's being taken now is in the different mode and is providing quite a bit of good information. In fact, the team here did not need to wait for the entire data take before preparing an attitude update reference, or attitude reference update. Additionally, here in the next couple of orbits, an exact time has not been settled on. The team is discussing another attempt at acquiring communications through the telescope's high-gain antennas. When that is done, the activity will be conducted at a 500 bit rate, which analysts say will provide a wider cone angle and should improve our opportunity to acquire the tracking and data relay satellite. At 2 days, 5 hours, 39 minutes mission elapsed time, this is Hubble Telescope Control in Greenbelt.
Discovery Houston, we're going to be giving up the TDRS to HST for about 10 minutes here, so we'll see you back in at about 6 hours even.
Okay, Jim, we copy.
And before we go, we might be getting a right RCS message because of the fuel tank heater cycling, no action required.
Thanks, Jim, we copy.
This is Hubble Telescope Control, Greenbelt, at 2 days, 5 hours, 50 minutes mission elapsed time. The mission control team has temporarily loaned the tracking and data relay satellite to the folks here in the Space Telescope Operations Control Center. And here in the next few minutes, we are about to attempt for the second time to acquire the tracking and data relay satellite using the Hubble Space Telescope's high-gain antennas based on the attitude reference update that was provided to the telescope a short time ago, and also using the 500-bit transmission rate, which provides a wider area of coverage or cone angle coming out of the antenna that perhaps will improve our chances of acquiring the the satellite. This attempt should be occurring here shortly when we begin commanding the telescope, and we'll be standing by to track the results of that. At 2 days, 5 hours, 51 minutes mission elapsed time, this is Hubble Telescope Control in Greenbelt. This is Hubble Telescope Control, Greenbelt. 2 days, 5 hours, 53 minutes mission elapsed time. We're continuing to stand by to attempt to communicate with the telescope through the high gain antenna system shortly. The bit rate of 500 bits should give us plus or minus 10.8 degrees. That's 10.8 degrees on either side of the center line of the antenna. Previously, at the higher rate, we had only about 6.2 degrees on either side of the center of the antenna. So this does broaden our area of coverage somewhat. Again, we are going to shortly be re-attempting to communicate with the Hubble telescope, or correction, have the Hubble telescope communicate through the tracking and data relays satellite with its high gain antennas, and this will be done based on an updated attitude reference provided to the telescope a short time ago.
This is Mission Control Houston at 2 days, 5 hours, 56 minutes mission elapsed time. We're standing by to acquire signal through the eastern satellite once again, and when we do that, we're hoping to bring down some television from the payload bay of Discovery. That's scheduled for 1:35 p.m. Central Daylight Time, or a mission elapsed time of 2 days, 6 hours, 1 minute.
This is Hubble Telescope Control, Greenbelt. 2 days, 6 hours.
Houston, we're back with you.
Okay, Jim, you're loud and clear.
And we are now in the process of sending a series of commands that will attempt to retry communicating direct from the telescope to the tracking and data relay satellite through the high gain antennas. And we'll stand by for the results. This is Hubble Telescope Control, Greenbelt. This is Hubble Telescope Control, Greenbelt. We have confirmation that we have achieved communication with the tracking and data relay satellite through the high gain antenna system. That confirmation at 2 days, 6 hours, 3 minutes mission elapsed time. Once again, we have acquired lock on the tracking and data relay satellite through the Hubble telescope's high gain antennas. This is Hubble Telescope Control, Greenbelt.
Discovery Houston, we're getting good payload bay camera views now, and we have a tags message coming on board.
Okay, we'll be watching for it. Okay, Houston, Discovery, we've got message 22 Bravo, 1 page total on board. Is that all you're sending at this time?
That's affirmative, Bruce. We may send you some other stuff later, but that's all we have now.
And this is Mission Control with that good news that the data is being transmitted through the high gain antenna on the Hubble Space Telescope. We're starting to take some payload bay views from Discovery. As the orbiter begins to approach the terminator from darkness, from daylight into darkness, and we're hoping to be able to get a sunset view as Discovery passes into darkness off the east coast of Africa.
This is Hubble Telescope Control, Greenbelt, at 2 days, 6 hours, 18 minutes mission elapsed time. We're continuing to have good communication with the Hubble telescope through the tracking and data relay satellite using the telescope's high-gain antennas. To recap how we were able to acquire a good lock on the tracking and data relay satellite with the telescope's high-gain antennas, we returned the telescope to its release attitude, which was part of a scheduled sequence of events today, and this placed the telescope's subsystems module aft end toward the sun. At that point, the telescope star trackers were commanded to take some data, which was provided to the ground. The analysts looked that over and prepared an attitude reference update, which was uplinked to the telescope. And this basically improved the telescope's knowledge of where it was, what its position was. It apparently was slightly off, up to approximately 6 degrees from where it thought it was. This corrected that. And following that, controllers here a short time ago attempted to regain communications through the high-gain antenna at a fairly low bit rate, 500 bits to be exact. At this rate, the cone angle or area of coverage is much greater than at the higher rates. This was successful, and this occurred at 2 days, 6 hours, 3 minutes mission elapsed time. Following that, the telescope was commanded to communicate at a higher rate of 4 kilobits, and this also was successful. And at the present time, the telescope is communicating with the tracking and data relay satellite through the high-gain antenna system at 4 kilobits. The high-gain antennas, there are 2 of them, and they are the primary communications link to relay science as well as engineering data to the ground during normal space telescope operations. Again, at approximately 2 days, 6 hours, 3 minutes mission elapsed time, we were successful in acquiring a lock on the tracking and data relay satellite with the Hubble telescope's high-gain antennas. And we're continuing to receive good communications with the telescope at this time. At 2 days, 6 hours, 21 minutes mission elapsed time, this is Hubble Telescope Control in Greenbelt.
Discovery Houston, just to give you a heads up.
This is Mission Control Houston at mission elapsed time of 2 days, 6 hours, 30 minutes. Our next television event will be on orbit 35 once we get back on the tracking and data relay satellite east. That downlink television is supposed to be some remainder VTR dump on the ion arc experiment, the student experiment aboard Discovery for the STS-31 mission. That television is scheduled to come down at 2:43 p.m. Central Daylight Time. That translates to a mission elapsed time of 2 days, 7 hours, 10 minutes. During the handover from the Orbit 1 team to the Orbit 2 team, the flight dynamics officer reported that Discovery was about 50 nautical miles behind the Hubble Space Telescope, and that rate was, that difference between the two was increasing at a rate of 1.2 nautical miles every orbit. That will eventually get up to about 54.7 nautical miles before we do a reaction control system burn, and that burn is scheduled for 2 days, 8 hours, 49 minutes, and that burn will slowly during the evening while the crew's asleep bring Discovery to a point about 40 nautical miles behind the telescope by the time the crew wakes up tomorrow, in the event that we would have to again rendezvous with the telescope on flight day 4 or flight day 5 to support a contingency extravehicular activity related to the aperture door should that not open properly during that activity tomorrow. Other activities ongoing aboard Discovery are some Earth observation photography. The crew was expected to take some IMAX footage over Brazil on the last pass a few minutes ago, and are continuing to take some still photographs in support of Earth observation and other activities. Discovery remains in a gravity gradient attitude, and that is nose pointing at the Earth, right wing into the velocity vector, and that detailed test objective with Discovery is scheduled to end at 2 days, 7 hours. Following termination of the gravity gradient DTO, the crew will maneuver to an IMU align attitude. That is to align the inertial measurement units aboard Discovery for the evening. The crew's pre-sleep activities begin at the termination of the gravity gradient DTO, and the crew is scheduled to go to sleep this evening at 2 days, 10 hours. All systems aboard Discovery continue to perform extremely well. There are no issues related to the vehicle being worked here in the control center as the Orbit 2 team continues to proceed smoothly through its shift. So as there are no issues being worked, so is it very quiet in the control center. And at 2 days, 6 hours, 34 minutes, this is Mission Control Houston.
Discovery Houston, we're back with you.
Line clear, Jim.
Okay, we'd had a dropout for a while, little comm problem, and then the TDRS zone of exclusion. Got a couple of things for you. During the next East TDRS pass, which is probably going to be about 25 or 30 minutes, we'd like, if you could, to give us the rest of the camcorder tape on the ion arc. And we'll give you a call right before that happens, but we thought you might want to take time to get it set up. Also, it looks like your LIO usage is kind of leveled out, and we'd like for you to cancel any exercise that you plan for the rest of the afternoon to decrease your putting any more carbon dioxide into the cabin.
Okay, now we understand, and Charlie's going to start setting up the camcorder.
Okay, and if we keep our LIO usage at the same rate, we probably can pick up exercise again tomorrow. We just want to make sure we can get through the rest of today on those old cans.
Okay.
Discovery Houston, we're wondering if you can give us a HumSep report on water accumulation and also a reminder to switch over to HumSep Bravo.
Jim, we were about to swap over. We did an inspection and there was no water.
Okay, Steve, thanks a lot.
Houston, Discovery.
Go ahead, Discovery.
Yeah, Jim, I guess from an IMAX point of view, the next thing, or the remaining thing that we show for today is a try to get a view of Japan a couple of revs from now. And I'm curious what the ground weather outlook for Japan is. We think we've been seeing a pretty good number of city lights from Japan over the last couple of night passes.
Yeah, and you're right, and we have another message for you. We were just waiting until we got closer. You're always a step ahead of us, Kathy. We think that the weather's going to be good there for your Rev 36 pass over Japan.
Okay, well, just remember they paid the crews to be ahead of MCC.
Y'all are doing a good job of it.
Well, it's rare that we manage to do it, so we make note of the few cases where we succeed.
Okay.
Jim, do you have a preferred time to do the Perla procedure in message 22 Bravo?
Steve, we just wanted to do that sometime when we could watch.
How about now?
That'd be great, Steve. We can watch now, and we'd like that.
Okay.
Okay, Jim, we're just about ready to send it. It should be coming now.
And we're receiving your downlink now, Lauren. It's looking good.
Roger.
The intro was really for the CDR, except he had his back turned. Hey, Jim, one thing that I do need to tell you, when you play this back, I got a little carried away with my VTO, with my camcording today, and I chopped the very first part of this off along with DTO 644 in doing the earlier part of that intro you saw with Lauren on the treadmill. So please tell Greg that I apologize for missing the very first part here, but I think he gets the parts he wants in this.
Okay, Charlie, thanks.
Oh, Jim, and one other thing that you might explain to those guys, because they probably were looking for the camcorder to be mounted on the arm, just like the 16 millimeter. But we decided, in the interest of time and in trying to get everything in while we were going to be live, that we just hold the camcorder off to the side. So I apologize for that part also.
Okay, Charlie. Looks like we're getting a pretty good view of it, though, so it looks fine to me. Thanks.
And Jim, it just occurred to me, I am not familiar with how the downlinking of the VTR works. Will you guys be able to have voice that's coming through this thing?
Charlie, we're not getting any voice right now.
Okay, I apologize for not talking to you then. Basically what you're seeing here, so you'll have it there, the first part was the uncharged part, just as we described, and this is paralleling the downlink that you got earlier, but we were not able to show you anything actually in the chamber, so we wanted to do this, and we've actually at this point started turning up the magnetic field and everything, so as you go along you'll see that the arc will start to get a little bit more erratic. Right now we have it in the orientation where the arc is along the orbiter's y-axis.
Okay, Charlie, that really helps me. I'm sure the folks who are watching the experiment closely understand pretty much what's going on, but it helps for the rest of us to have a little commentary. Thank you.
Okay, and I apologize for that. And what if they put this side by side with the voice and stuff that we gave you this afternoon, then they'll be able to see the arc as we were describing what you could not see at that time.
Okay, thanks.
And basically, just to keep me from talking a lot, I'll give you a heads up when we change orientation and tell you what I think we're doing as best I can remember.
Okay, that sounds great. And I got a thumbs up from the payloads folks.
This is Mission Control, Houston. This video is of the student experiment that was selected in 1982 to fly aboard a future space shuttle mission. This experiment, entitled Investigation of Arc and Ion Behavior in Microgravity, was submitted by Greg Peterson. Peterson, now a senior studying chemistry and biology at Utah State University.
And Jim, one more thing that I think I mentioned this afternoon for people who are not familiar with the experiment is, I know it's hard, but just disregard the top and the bottom arc because they're just reflections from the case glass itself. On the right-hand side, if you can see it well enough, you can see the charge in the magnetic field as it steps up. There are 2 meters in there, and the one on the right is, if I remember correctly, showing you how the magnetic field is being increased incrementally.
Okay, Charlie, thanks. I didn't know there was just one.
And I think it just went up to the level of 5, which is max. And from here, you'll start seeing it go back down. I was holding the camcorder by hand, so I can't guarantee that that's going to stay in the frame.
Okay, yeah, we have that in the frame, but we cannot read the meters. We can see them, but can't read the numbers.
Okay, I understand. We just dropped it back down to level 4. And what we were doing was incrementally increasing and decreasing every 20 seconds. Just drop back down to 3. And one thing we did notice is that although the amplitude of the oscillations on the arc, or the erraticness of the arc, seemed to decrease, it never did get back down to where it was before we put the magnetic field, the charge on the box. And we had been told about that. There, it just went back down to level 2. So I know you don't have anything to compare it to, but when we get back down 2 more increments, it'll be to where there's no charge at all or no magnetic field, but you'll still see some of the erratic oscillations on the arc, and that's just because of the residual field that remains on the box once you charge it the first time. I think we just went down to level 1.
And just a heads up, Charlie, we got about 5 minutes left before we give up the TDRS again.
Okay. Okay, and Jim, I think that may have been the end of it. I know we just turned the power off, and it looks like it's back down in the Y orientation. So I think you can go ahead and quit. And again, my apologies for having been overzealous with the camcorder and erasing part of it, but hopefully that'll be of some assistance also.
Okay, Charlie, thanks. That was a real good report. We appreciate it.
Houston Discovery.
Go ahead, Lauren.
We had not been doing the cable positioning for KU band and pre-sleep. Is that the same tonight?
That's affirmative, Lauren. It's not required tonight. And we're going to give up the TDRS in about 3 minutes, and we'll be back with you 20 minutes later at about 7:50.
Okay, copy 750. Does that mean you want us to go ahead and maneuver to the IMU line attitude?
Stand by, Lauren.
And Jim, you getting the camcorder TV?
We're through with that now, Lauren. And we're going to be LOS in about a minute, and Lauren, we'd like for you to go ahead and do the IMU align maneuver on time.
Okay, we'll do IMU align start priority 1 on time.
This is Hubble Telescope Control Greenbelt at 2 days, 7 hours, 32 minutes mission elapsed time. We've continued to have good performance in terms of receiving data through the high-gain antennas since we brought them online this afternoon. However, in the last 40 minutes, we have been unable to command the telescope through our low-gain antenna system, and analysts here in Greenbelt and in Huntsville are taking a look at that to determine the reason that we have not been able to activate our forward link through the low-gain antenna. Again, high-gain antenna system continues to perform. However, all commands sent to the spacecraft are sent through the low-gain system, not through the high-gain antennas. Additionally, at approximately 2 days, 6 hours, 10 minutes mission elapsed time, we had an indication of a problem with one of the 4 gyros on board the telescope, gyro number 3, and the computer took that gyro offline. Analysts have taken a look at that and have determined that there was, in fact, no problem with that gyro system. And once we regain the ability to command the telescope, we will go ahead and bring that gyro back online. Again, that's a no-impact situation. The telescope operating normally under the control of its other 3 gyros. However, after evaluation, there is no indication of any problem with the gyro number 3, which was taken out of service by the computer system. And once we reacquire capability to command the telescope, we will again put that gyro back in service. Additionally, at approximately 4:30 Eastern Daylight Time this afternoon, there will be a change of shift briefing from the Space Telescope Operations Control Center with Director of Orbital Verification Mike Harrington. That briefing will be carried on NASA Select and will be an interactive briefing. It will originate from the Goddard Space Flight Center News Center. That time again for the briefing is approximately 4:30 p.m. Eastern Daylight Time this afternoon. At 2 days, 7 hours, 35 minutes mission elapsed time, this is Hubble Telescope Control, Greenbelt.
This is Hubble Telescope Control, Greenbelt at 2 days, 7 hours, 44 minutes mission elapsed time. Our next television event will be the Space Telescope Operations Control Center change of shift briefing with outgoing Director of Orbital Verification Mike Harrington. That briefing scheduled to begin at 3:30 p.m. Central Daylight Time, originating from the Goddard Space Flight Center.
And this is Mission Control Houston at approximately 4 p.m. Central Daylight Time following the stock change of shift briefing. There will be an STS-35 status briefing. That is the mission that follows STS-31, and that briefing will be conducted by Captain Robert Crippen, who is the Director of the Space Shuttle Program. That will be in Building 2, Room 135 here at the Johnson Space Center. Again, that briefing is upcoming at 4 p.m. Central Daylight Time following the stock change of shift briefing.
Discovery Houston, we're back with you on the East Satellite.
Houston Discovery.
Go ahead, Charlie.
Yeah, Jim, while you guys were gone, we got an S-69 fuel cell message during the purge on fuel cell number 2, and it was right at the end, or toward the end of it. We saw the O2 flow jump up to 11 momentarily, and then it settled back down to normal, somewhere in the range of about 5.0, and very shortly after that, the purge on that fuel cell stopped and it shifted to 3, but that's what that S-69 fuel cell is you're going to see.
Okay, we were taking a look at that. Thanks, Charlie. Okay, Charlie, we're continuing to look at that. We think maybe it's an erratic transducer, but we'll take a closer look and let you know. Also, just a little reminder, we don't want you to change out your LiO cans as part of your normal pre-sleep activities. We want to wait until we get a message.
Okay, copy.
And this is Mission Control Houston at 2 days, 7 hours, 52 minutes mission elapsed time. That discussion was on the fuel cell purge limit, which is a normal operation aboard the orbiter. The O2, or the oxygen purge limit, is 10 pounds per square inches. That flows into the tank. And the discussion was that that could possibly be just a transient that jumped that up to 11, which sounded an alarm aboard the vehicle. and the Eagle officer has taken a look at that. The other part of that discussion was related to the LiO canisters, or the lithium hydroxide canisters that remove the CO2 from the air, and they were just notifying the crew to leave the ones in there and don't do the normal change out until they reach the limit, which is 7.6 on the PSI. Right now that cabin PPCO2 limit is 7.09, so they've got a while before they would be required to change out those LiO or lithium hydroxide canisters.
Houston Discovery.
Go ahead, Lauren.
Do you need any of the
Yeah, Lauren, we do not need the IMU data. We have it. Thank you.
Okay, thank you.
And Discovery, we're going to be LOS in about 2 minutes. We'll see you back at 8:16.
Okay, Houston.
Discovery, Houston, before we go LOS, if we still have you, we'd like for you to stop your maneuver and go back to the IMU align attitude. That's the attitude we'd like to use for the burn.
Okay, we copy.
Yeah, we understand that's a change to the flight plan, but that's what we'd already worked up, so we'd like to do that now. Discovery, Houston, we're back with you, and we have your burn pad when you're ready to copy.
Okay, Jim, stand by just a second. Go ahead, Jim.
Okay, your maneuver pad for NC2, it's RCS select, multi-axis, TV roll 180, trim load is not applicable, weight 20479er1, TIG 02 slant 08 colon 49er colon 11 decimal 0. Your PEG 7 targets, delta VX negative 001 decimal 1, delta VY and delta VZ are all balls. Maneuver attitude, roll 332, pitch 169er, yaw 051, delta V tote 001 decimal 1, T go 00 colon 04, V go X negative 001 decimal 00, V go Y plus 000 decimal 08, V go Z negative 000 decimal 44. Your target HA is 334, HP plus 330, and all of the notes are not applicable.
Okay, Jim, you ready for readback?
Yes, go ahead, please.
RCS select multi-axis TV roll 180. Trim is NA. The weight 204791. TIG 02 slant 08 colon 49 colon 11 decimal 0. PEG 7 delta VX negative 1 decimal 1. Y and Z are all balls. Maneuver at is roll 332, pitch 169, Yeah, 051. Delta V tow to 001.1. Tigo 00:04. Vigo X minus 001.00. Y plus 000.08. Z is minus.
Our next television event will be the Space Telescope Operations Control Center change of shift briefing with outgoing Director of Orbital Verification, Mike Harrington. That briefing scheduled to begin at 3:30 p.m. Central Daylight Time, originating from the Goddard Space Flight Center.
And this is Mission Control Houston at approximately 4 p.m. Central Daylight Time following the stock change of shift briefing. There will be an STS-35 status briefing. That is the mission that follows STS-31. And that briefing will be conducted by Captain Robert Crippen, who is the Director of the Space Shuttle Program. That will be in Building 2, Room 135 here at the Johnson Space Center. Again, that briefing is upcoming at 4 p.m. Central Daylight Time following the stock change of shift briefing.
Discovery Houston, we're back with you on the East Satellite.
And Houston Discovery.
Go ahead, Charlie.
Yeah, Jim, while you guys were gone, we got an S-69 fuel cell message during the purge on fuel cell number 2, and it was right at the end, or toward the end of it. We saw the O2 flow jump up to 11 momentarily, and then it settled back down to normal, somewhere in the range of about 5.0. And very shortly after that, the purge on that fuel cell stopped, and it shifted to 3. But that's what that S-69 fuel cell is you're going to see.
Okay, we were taking a look at that. Thank you, Charlie. Okay, Charlie, we're continuing to look at that. We think maybe it's an erratic transducer, but we'll take a closer look and let you know. Also, just a little reminder, we don't want you to change out your LiO cans as part of your normal pre-sleep activities. We want to wait until we get a message.
Okay, we copy.
And this is Mission Control Houston at 2 days, 7 hours, 52 minutes mission elapsed time. That discussion was on the fuel cell purge limit, which is a normal operation aboard the orbiter. The O2, or the oxygen purge limit, is 10 pounds per square inches. That flows into the tank. And the discussion was that that could possibly be just a transient that jumped that up to 11, which sounded an alarm aboard the vehicle. And the Eagle officer has taken a look at that. The other part of that discussion was related to the LiO canisters, or the lithium hydroxide canisters that remove the CO2 from the air. And they were just notifying the crew to leave the ones in there and don't do the normal change out until they reach the limit, which is 7.6 on the PSI. Right now that cabin PPCO2 limit is 7.09, so they've got a while before they would be required to change out those LiO or lithium hydroxide canisters.
Houston Discovery.
Go ahead, Lauren.
Do you need any of the...
Yeah, Lauren, we do not need the IMU data. We have it. Thank you.
Okay, thank you.
And Discovery, we're going to be LOS in about 2 minutes. We'll see you back at 8:16.
Okay, Houston.
Discovery, Houston, before we go LOS, if we still have you, we'd like for you to stop your maneuver and go back to the IMU align attitude. That's the attitude we'd like to use for the burn.
Okay, we copy.
Yeah, we understand that's a change to the flight plan, but that's what we'd already worked up, so we'd like to do that now. Discovery, Houston, we're back with you, and we have your burn pad when you're ready to copy.
Okay, Jim, stand by just a second. Go ahead, Jim.
Okay, your maneuver pad for NC2, it's RCS select, multi-axis, TV roll 180, trim load is not applicable, weight 20479er1, TIG 02 slant 08 colon 49er colon 11.0. Your PEG 7 targets, delta VX negative 001.1, delta VY and delta VZ are all balls. Maneuver attitude, roll 332, pitch 169er, yaw 051. Delta V tote 001.1, T go 00:04, Vigo X negative 001.00, Vigo Y plus 000.08, Vigo Z negative 000.44. Your target HA is 334, HP plus 330, and all of the notes are not applicable.
Okay, Jim, you ready for readback?
Yes, go ahead, please.
RCS select multi-axis TV roll 180. Trim is NA. The weight 204.791. TIG 02 slant 08 colon 49 colon 11.0. PEG 7 delta VX negative 1.1. Y and Z are all balls. Maneuver at is roll 332, pitch 169, yaw 051. Delta V towed is 001.1, TGO 00:04. Vigo X minus 001.00, Y plus 000.08. Z is minus 000.44. Okay, 334, HP plus 330. The notes are NA.
And that's good readback. Your targets are coming on board now. And I've got several other pre-sleep configuration notes for you when you're ready for those.
Okay, go ahead.
Okay, first of all, for your cryo config, after the fuel cell purge, which I believe you've already done, and after your 10-2 maintenance, which we need for you to do, on panel R1, O2, H2, manifold valve, tank 2, that's 2 switches to closed, O2, H2, tank 3, heaters alpha and bravo, 4 switches to auto, and O2, H2, tank 1 heaters, alpha and bravo, 4 switches to off. Over.
Okay, Jim, we copied on R1. You want us to close O2 and H2 manifold valves, tank 2, 2 switches to close, O2, H2, tank 3 heaters, alpha and bravo, 4 switches to auto, O2, H2, tank 1 heaters, alpha and bravo, 4 switches to off.
That's good readback, Charlie. And I had said that was to be done after the 10-2 cabin maintenance. That was another thing we want to remind you we need to do that, and that's contingency EVA checklist, page 6-7. And we have another...
Okay, we copy, and you want to bump the... you want us to keep going until we bump the PPO2 up to 276 first, the O2 flow first?
Stand by, let me check. And Charlie, that's correct. We do want you to do it that way.
Okay.
I have one other one for you. A pre-sleep modification to the orbit checklist for pre-sleep, because the Pod B heaters are causing our aft RCS tank temperature to violate the FDA. We'd like for you to reconfigure while you're doing your pre-sleep activities to the following. On panel A14, RCS ohms heaters, left pod, A auto, B off. And the right pod, A auto, B off. Over.
Okay, Jim, we copy those also, and we'll put those in work right now. On panel A14, RCS ohms heater, left pod, alpha, auto, bravo off, right pod, alpha, auto, bravo off, and that's complete.
Okay, we see that one, and that's looking good, Charlie. Thanks. I have one other thing about the LIO changeout. We don't want you to do that now, but I can go ahead and give you the CAN number so you can get them ready if you'd like. We want you to put LIO CAN number 6 in position alpha and LIO CAN number 2 in position bravo. And we'll wait until either we get the message when we get to 7.6 millimeters of mercury on the PPCO2, or the last thing before you go to sleep. And whenever that happens, we would like for you to give us a call and confirm that that's been done. And with this change, we predict that the PPCO2 is going to go down real low during the night to about 2 millimeters of mercury, and it should work just fine through the night and into post-sleep tomorrow.
Okay, we copy that, and we're already showing 7.6. We haven't gotten the message yet, but you want us to wait until we get the SM?
That's affirmative. We'd like for it to be as late as possible.
Okay, we copy. And Houston, the LIO has been changed out.
Okay, Steve, thanks.
And this is Mission Control Houston at 2 days, 8 hours, 41 minutes into the flight of STS-31. Back here in the control center, preparations are being made aboard Discovery for the NC2 burn. That's a reaction control system burn that will be upcoming in about 7 minutes. The time of that burn and actual numbers is 2 days, 8 hours, 49 minutes, 11 seconds. That burn will last for 4 seconds and will change the delta velocity of Discovery by 1.1 feet per second. Following the burn, Discovery will be in a 334 by 330 nautical mile orbit, and throughout the evening, throughout the crew's sleep period, that will slowly bring Discovery back to a point where it's about 40 nautical miles behind the Hubble Space Telescope by the time the crew wakes up tomorrow morning. Again, that burn upcoming in about 6.5 minutes. Other activities, the crew was read up several pre-sleep notes. Most of those are just maintenance items that they do prior to going to bed, including the configuration for their cryo systems and also the maintenance procedures for the 10.2 cabin pressurization. Those are all normal configurations that are done under the circumstances. Also, the crew got a message that their LiO canisters needed to be changed. They reached the 7.6 millimeter level of mercury and therefore changed out the LiO canisters, and that level has since begun to reduce. So everything on the Orbit 2 shift continuing to go very smoothly. We're 5 minutes and 20 seconds away from the RCS burn that will slowly catch Discovery up with, to put it, but 40 miles behind the Hubble Space Telescope. And all continuing to go smoothly. We're at 2 days, 8 hours, 44 minutes mission elapsed time. This is Mission Control.
And this is Hubble Telescope Control Greenbelt at 2 days, 8 hours, 44 minutes mission elapsed time. During the last hour or so, controllers here in the Space Telescope Operations Control Center were able to reestablish command capability with the Hubble Space Telescope, that occurring about 45 minutes ago. Commands are currently being sent up to the telescope to bring the rate gyro number 3 back online. Initial indications are that that sequence of events has been completed, and we are currently awaiting verification that that gyro is back online and operating. Throughout the next few hours, the Shift 2 orbital verification team will be conducting a number of activities in regard with the pointing control system of the telescope. This activity in preparation for the opening of the aperture door set for sometime around noon Eastern time tomorrow. At mission elapsed time 8 hours 45 minutes, this is Hubble Telescope Control Greenbelt.
This is Mission Control. The ground controller reports that the orbiter is in a good configuration for the upcoming RCS burn. Now about 1 minute and 20 seconds away from the burn, which will last for about 4 seconds.
Go ahead, Discovery.
Okay, the burn's complete. We just want to know if you want us to go to the flight plan edit.
That's affirmative, Charlie. The minus ZLV minus YVV that's listed at about 8 hours and 10 minutes in your update.
Okay, we copy.
And this is Mission Control Houston. The report from the crew was that the burn was complete. and the orbiter is now maneuvering to its sleep attitude, which is payload bay to the Earth, nose north.
Houston Discovery.
Go ahead, Discovery.
Okay, Jim, first of all, the cryo config is complete, and if the IMAX folks are ready, I'll give them a synopsis of our day's activity.
We're ready for that. Go ahead.
Okay, we got 5 Earth obs scenes today, starting in the morning on the ASA 250 film, a 30-second shot that we mentioned to you looking across Africa to the west, across Botswana, Etoshapan, and the Namib. Second shot, western USA, starting at the San Francisco area, going in over the basin and range. That's on ASA 25 film, also 30 seconds. Third shot, the rainforest shot as requested with the west coast of South America and the Andes in view, and then looking out across the popcorn, cloudy Amazon basin, ASA 25, 30 seconds. We shot a second chunk of that at our own discretion further over in the rainforest itself. That's also ASA 25, and about a 12 to 15 second shot, a little short. I'm sorry, probably a 15 to 20 second shot, a little short. And then finally, we took a stab at the Japan shot here, this last rev. Sun angle looked reasonable, a little lower than the others of the day. It was, however, very hazy over the island group. You could see the summits of the mountains and a little bit of the land mass of the islands, but a lot of haze in the vicinity. And I won't bother to give you lenses or f-stops unless those folks really needed the lenses were all as requested.
Okay, Kathy, thanks, and we'll check on the f-stop stuff. If they need that, we'll get back with you.
Okay, and we have that all logged on board, of course.
Okay.
This is Mission Control Houston. That report was on the IMAX film photography that was taken during the day. The report given by Mission Specialist number 3, Kathy Sullivan. At the same time, Flight Activities Officer Neil Woodbury reports that Discovery is in its minus ZLV minus YVV attitude. That's the sleep attitude that the crew will use this evening. That is a payload bay to the Earth, nose north attitude.
And Kathy, we do not need anything further for the IMAX folks. Thanks.
You're welcome.
This is Hubble Telescope Control Greenbelt at 2 days, 9 hours, 1 minute mission elapsed time. Second shift director of orbital verification, Ron Schlagheck, has confirmed that gyro number 3, that gyro taken offline by the telescope software, is back up and verified running properly. So the Hubble Space Telescope now operating with all 4 of those gyros operating properly. Again, that was a software problem that took that gyro offline earlier this afternoon. It was not a problem with the gyro, and that gyro is up and running properly at this time. The controllers here are continuing to go through several activities with the pointing control system of the telescope. The earlier command capability problem has also been corrected, so commands are being...
Okay, Jim, 10.2 cabin maintenance is complete, cryo reconfig is complete.
Okay, Charlie, and just for reference, tomorrow night and future nights, we'd prefer to have the 10.2 maintenance done before we do the cryo reconfig, if possible. Okay, thanks.
Commands currently being sent to the spacecraft without any problems. So all going well again here in the Space Telescope Operations Control Center in Greenbelt, Maryland. Controllers here as well as analysts at the Huntsville Operations Support Center and at Marshall Space Flight Center in Alabama, continuing to watch all the systems on the spacecraft at 2 days and 9 hours, 3 minutes mission elapsed time. This is Hubble Telescope Control, Greenbelt.
This is Mission Control, Houston. Our next television event will be some unscheduled shuttle television from Discovery on orbit 37 once we acquire a signal on the eastern satellite. That upcoming at 4:56 p.m. Central Daylight Time. That translates to a mission elapsed time of 2 days, 9 hours, 22 minutes. We hope to be taking some payload bay views from Discovery for hopefully for about a half an hour. Again, that television upcoming at 4:56 p.m. Central Daylight Time. That's in about 6 minutes. This is Mission Control, Houston. Now taking payload bay views from Discovery as the orbiter crosses the South American continent, approaching the terminator from daylight into darkness. And this is Mission Control as the orbiter Discovery passes from daylight into darkness. Orbit 2 Flight Director Milt Heflin polling the room to see if there are any last messages from flight controllers to be sent up to the crew before we put them to bed. Now official sleep scheduled to begin in 37 minutes. And this is Mission Control. We're now taking views from camera C, camera Charlie. That's on the aft bulkhead looking forward. As the camera pans to the left, you can see the remote manipulator system armed in its stowed position on the port side or left side of the vehicle. Now panning down into the payload bay where the Hubble Space Telescope was cradled prior to being deployed yesterday afternoon. This is Mission Control Houston. We're now taking a view out into space, and in the center of the screen is the constellation Orion. And this is Mission Control Houston. We're now looking at the brightest star in the sky, Sirius. Also the name of the flight director for the Orbit 2 team is Sirius, Milt Heflin. Payload bay view now of the constellation Orion once again. Very distinctive constellation in the sky. Orion the hunter. His belt is made up of the 3 vertical stars in the center of the picture. The 4 corner stars make up his shoulders and his knees, with the smaller stars making up the sword dangling from Orion's belt. Now continuing to take payload bay views from the camera C. The bright star in the center of the picture near the Earth's limb is the planet Jupiter. On the left side of the picture are storms on the surface of the Earth. Now as Discovery approaches orbit 37, passing over the continent of Africa. With the cameras aboard Discovery, we're attempting to track a bright star, or in this case planet, as it sets through the Earth's limb. That in support of an investigator, Alan Stern from the University of Colorado, who is interested in investigating high clouds, which are basically formed of ice from the 80 to 100 kilometer range above the Earth's surface. And by using a light source behind those clouds, he's able to gather data in his investigations.
Discovery Houston, we've been watching through the payload bay cameras. We just watched Jupiter set behind the Earth. And I've got a couple of things for you before you go to sleep if you're ready.
Okay, stand by one, Jim. Okay, Jim, go ahead.
Yeah, first of all, we'd like for you to go back to DAP Alpha. And wanted to let you know that Flight Day 4 will be as published in the flight plan. We do have a Flight Day 4 rendezvous plan if it's required. We don't expect for it to be, but if we needed it, we would have it available. On your LIO canister situation, it looks like we have already taken care of covering an extra day, so we're in good shape there. We'll continue to watch that closely and use the old cans to try to maximize our LIO canister situation. The O2 flow that Charlie reported that was high during the fuel cell purge, we believe was real. So we would like for him to, on panel R12, take the fuel cell purge valve number 2 to closed. And tomorrow we will probably just purge fuel cells 1 and 3. We'll pass that up to you in the morning mail. Over.
Okay, Jim, you got DAP A, and Charlie copied about the purge valve for fuel cell 2. And I guess if you're planning Flight Day 4 as published, that means the checkout's going well, and if you got an update on the status?
Yeah, we'll get one for you real quick. The latest thing, we've heard several things lately, and we'll get you the final word on the update before we say goodnight.
Okay, thanks.
And this is Mission Control with about 14.5 minutes before putting the crew to bed for the evening officially.
Incidentally, Jim, thanks to you guys for the evening newspaper. We appreciated that.
Okay, we'll try to send you some more of that too when we get a chance. We just had limited KU
yeah, that'd
band.
be great.
Yeah, we have some more to send you, but we had limited KU band today, so we'll send you more as we get time.
Okay, thanks a lot. Yeah, we knew you were hurting for coverage today.
And this is Mission Control. Discovery now 2/3 of the way across the continent of Africa. Still taking some payload bay views of the Earth as Discovery passes across the continent. Seeing some fairly heavy lightning activity and thunderstorm activity on the surface of the Earth.
Discovery Houston. Steve, we've got the HST status for you. It looks like so far they have successfully gotten telemetry through the high gain antenna. They have completed the slew test of the solar arrays, and they've been catching up on their timeline. They'd gotten a little bit behind because of some bad comm through TDRS, but they have improved their antenna pointing accuracy now, and they've got good comm and are really on their way to catching up. It looks like the aperture door opening is going to happen tomorrow at an MET of about 2 days and 22 hours. So things are going pretty well right now. And we don't have anything else for you. Everything looks like it's going well for getting ready to go to sleep. So the Orbit 2 team has enjoyed being with you today, and we'll be turning over in about an hour or so to the planning team, and they'll look after you while you're sleeping.
Okay, well, that's good news about the telescope, and we've enjoyed working with you today, and we'll look forward to talking with you tomorrow.
Okay, good night.
And Jim, one last thing. Just want to let you know that according to our bookkeeping, we got everything done today that was scheduled in the flight plan. and or passed up by you folks, and so looks like a good day overall.
Okay, Lauren, good work. We appreciate y'all squeezing everything in like that. That's good. Thanks. See you later.
Roger that.
This is Mission Control Houston. We're now about 1 minute and 20 seconds from losing signal through the eastern satellite. We have given our good nights to the crew, although their sleep cycle doesn't start officially for another 5 minutes. All systems aboard Discovery continue to perform very well. We have concluded the downlink television from the payload bay. However, the crew will leave the payload bay cameras in the command mode for the evening, and there likely will be some further downlink television during the night while the crew's asleep, being commanded as the cameras are commanded from the ground by the integrated communications officer. At 2 days, 9 hours, 55 minutes, this is Mission Control Houston.
And Discovery, we believe the thermal message you got is a transducer, but we're evaluating it.
Thanks, Houston. We copy.
Discovery Houston, we believe now that that is a real heater failure. On panel L2, we'd like for you to take the FES feedline heater from 2 to 1.
Is that both of the heaters?
Just feedline A, Lauren.
Okay, A is going to 1.
This is Mission Control Houston. Environmental and Consumables Officer reports that the feed line, one of the 2 feed lines to the flash evaporator system, the heater on that feed line was reading a little high, and that was the conversation that was just transmitted between Capcom Jim Voss and the crew aboard Discovery. Crew was asked to switch from from the feed line A heater 2 over to the 1 side.
And Houston Discovery, that's the same reading indicating high again.
Okay, Lauren, we're evaluating it. Discovery Houston, Lauren, we're continuing to evaluate this heater. We believe there may be some localized heating in there, but we're not sure yet. We'll continue to look at it. That temperature's at 144 now, and the limit is 140. We're going to Timbu a new limit to make that 150 to avoid any future nuisance alarms, and we'll continue to watch that closely for you and try to figure out exactly what happened.
Okay, Jim. Be advised, we read 135 now, so it's started back down. You may be looking at some kind of shift or bias or something in the sensor or the controller.
Okay, and we'll keep watching it.
And this is Mission Control Houston at 2 days, 10 hours, 24 minutes. The last part of that discussion was that the switch from the line 2 to line 1 on the flash evaporator system feed line heater appears to have stopped the overtemp, and the temperatures have since been dropping, and the latest reading is 132 coming down. The limit on that is 140 degrees, and on line 2 that reading got up to 144. Once the heaters were switched from the 2 side back to the 1, the temperature remained stable because of localized heating, it's believed. And then as the A-line heater was cut off, or the number 2 heater was cut off, line 1 then began to cool down also. The environmental consumables officer will continue to monitor that, and appears to be no concern for the crew.
This is Hubble Telescope Control Greenbelt at mission elapsed time 2 days, 10 hours, 30 minutes. Activities here in the control center at Greenbelt are continuing with the pointing control system activities. We had confirmation a few minutes ago of the completion of a sequence in which the solar arrays were slewed to 12 degrees and then brought back up to the 3-degree positioning. That activity has gone very, very well. Just a few minutes ago, the decision was made to move up the opening of the Hubble Space Telescope aperture door to a mission elapsed time of about 2 days, 22 hours, or somewhere between 6:30 and 7 a.m. Replanning of activities here and deferring some non-critical activities till a little later in the mission has allowed us to move that aperture door window of opportunity up to that time. Again, at this point, we will be looking at an opening of the aperture door on the Hubble Space Telescope somewhere between 6:30 and 7 a.m. Eastern Daylight Time tomorrow morning. At mission elapsed time 2 days, 10 hours, 31 minutes, this is Hubble Telescope Control Greenbelt.
And this is Mission Control Houston. Our next television event is scheduled, will be a replay of Flight Day 3 activities. That replay will begin in about 10 minutes at 6:15 p.m. Central Daylight Time, or a mission elapsed time of 2 days, 10 hours, 41 minutes. Again, that replay upcoming at 6:15 p.m., and it will run for approximately 35 minutes. Following the replay of Flight Day 3 activities, our next scheduled event after that would be a change of shift briefing with off-going Orbit 2 Flight Director Milt Heflin. That briefing is currently scheduled for 7 p.m. Central Daylight Time in Building 2, Room 135. Any news media wishing to take part in that press briefing should call the JSC News Center at 713-483-5111. And this is Mission Control Houston. Again, Flight Day 3 replay coming up at 6:15 p.m. and that replay will last for about 35 minutes. The ECOM officer just reported to the flight director that a localized hotspot on the heater line to the flash evaporator system, which is basically a hot slug of water in that line, that has been sitting there most of the day while the flash evaporator system was in standby, was the cause of the message that the crew got a short while ago. And when the flash evaporator system moved out of standby, that's when the slug of water began to move through the line as it should have, and tripped the message that the crew saw on one of their cathode ray tube or computer screens on board the vehicle. As a precaution, the ECOM officer will TIMBU that line, and TIMBU stands for Table Maintenance Block Update, which is basically a change in the where the alarm would sound from the normal 140 degrees up to 150 degrees, just as a precaution so as not to wake the crew during their sleep shift this evening. However, the temperatures have continued to decrease as they should once the two heaters were swapped, and there seems to be no concern whatsoever for having any problems with that temperature getting above the normal limit of 140 degrees. Still standing by in about 2 minutes for the replays of Flight Day 3 activities. Again, those replays will last for 35 minutes. We're currently at 2 days, 10 hours, 39 minutes mission elapsed time. This is Mission Control Houston.
This is Mission Control Houston. We're now receiving some unscheduled live television from Discovery's payload bay cameras. Those cameras are being remotely operated by the Integrated Communications Officer here in the Control Center. Members of the planning shift, the overnight shift of flight controllers, have taken the helm here in the Control Center. Currently, Discovery is over that part of the world that is in night, and television from Discovery is television is kind of non-distinct since we're looking at a nighttime world. There may be a possibility for picking up lightning flashes over Africa during this pass, which should be upcoming shortly. Also, a change of shift briefing with off-going Orbit 2 Flight Director Milt Heflin has been canceled. That change of shift briefing was scheduled for 7 p.m. Central Daylight Time, and it has been canceled. This is Mission Control Houston. The television from Discovery's payload bay cameras is currently displayed on the right-hand screen to the right-hand side of the world tracking map at the front of the Control Center. Controllers are watching that television. We're expecting to see lightning flashes. There's a large thunderstorm directly off the coast of Africa, the west coast of Africa, which Discovery is now passing. That information has been supplied by the Weather Center here at the Air Force Meteorology Group here in the Control Center.
This is Hubble Telescope Control Greenbelt at mission elapsed time 2 days, 11 hours, 25 minutes. The controllers here in the Space Telescope Operations Control Center are continuing with a number of sequences designed to check out the pointing control system on the Hubble telescope in preparation for tomorrow morning's opening of the aperture door on the telescope. It was announced earlier this evening that the opening of that aperture door, previously planned for around noon Eastern time tomorrow, had been moved forward to somewhere between 6:30 and 7 a.m. Eastern time tomorrow. That being accomplished through replanning actions and some non-essential activities being delayed later into the orbital verification period. Several problems that cropped up earlier in the day have been corrected. An erroneous reading from the software concerning one of the gyros, that being gyro number 3 in the telescope, shut down that gyro for a period of time. Spacecraft was operating on 3 gyros as opposed to the normal complement of 4. A series of commands was sent up about 3 or 4 hours ago, which brought that gyro back online, and controllers here determined that there was nothing at all wrong with the gyro. It was an erroneous reading. A problem with commandability through the low gain antennas was also cleared up. Commanding has been ongoing now for several hours here in the control center. Went through a period of time of about an hour where we had lost command capability with the spacecraft. That was cleared up about 3.5 hours ago when we also had changed the attitude of the spacecraft and recaptured our lock-on with the high-gain antenna on the spacecraft. Again, the controllers here continuing to activate and check out portions of the pointing control system in preparations for the opening of the Hubble Space Telescope's aperture door tomorrow morning between 6:30 and 7 a.m. Eastern Time. Analysts at the Huntsville Operations Support Center, the Marshall Space Flight Center in Huntsville, Alabama, continuing to monitor all the systems of the spacecraft, all looking well at this time in preparations for tomorrow's aperture door opening. At mission elapsed time, 2 days, 11 hours, 29 minutes. This is Hubble Telescope Control Greenbelt.
This is Mission Control Houston. We have been picking up some lightning from television from Discovery's payload bay cameras as it crosses over the Middle East, headed towards sunrise. This is Mission Control Houston. Discovery is now moving into sunrise over the Middle East as it completes a pass under the Tracking and Data Relay Satellite East. We're now about a little over 3 minutes away from loss of signal with Discovery as it passes through the zone of exclusion. And now we're receiving a picture of Discovery's payload bay, very empty, with Hubble Space Telescope about 50 nautical miles ahead of the spacecraft now. This is a shot from a remote-controlled television camera at the forward left-hand corner of the payload bay. We've now lost communications with Discovery for a period of expected to be about 3 minutes long as it passes out of range of both tracking and data relay satellites. Here in the control center tonight, most of the activities are focused on possibilities that events that could happen but are hoped not to, planning for various timelines in case there is a problem with Hubble Space Telescope and Discovery must go back and rendezvous with the telescope in order to attempt to repair it. If everything remains normal, tomorrow's timeline and crew activities should be about the same as has been pre-planned. Some of the adjustments and details to be worked out on those potential timelines are adjusting the burns that would need to be performed for Discovery to move up and rendezvous with Hubble. On board Discovery at present, the crew is almost 2 hours into their current sleep period and 6 hours and 17 minutes away from their wake-up call. All systems are functioning smoothly and flight controllers here have spotted no problems. At 2 days, 11 hours, 42 minutes mission elapsed time, this is Mission Control Houston. This is Mission Control Houston. Our next television event this evening will be a replay of Flight Day 3 activities. That will occur at 9 p.m. Central Daylight Time, or 2 days, 13 hours, 26 minutes mission elapsed time. Again, a replay of Flight Day 3 activities, highlights from today aboard Discovery at 9 p.m. Central Daylight Time. This is Mission Control. We're now receiving live television again from Discovery from the Tracking and Data Relay Satellite Western as it passes over the Pacific Ocean. Discovery is currently at a 333 nautical mile high altitude. This is Mission Control Houston. We're continuing to receive live television from Discovery's payload bay camera. We're receiving it from the Delta camera, or the forward left-hand side camera in the payload bay. It's being remotely controlled by the integrated communications officer here in the control center. According to Earth observation specialists here at the Johnson Space Center, the approximate distance in this picture to the limb of the Earth, that horizon of the Earth, from the center of the picture to the horizon is about 900 nautical miles. That's about twice as far as we normally see on a standard shuttle flight, with the altitude of about 160 nautical miles. This is Mission Control Houston. Discovery is now on its 39th orbit. We have been receiving some intermittent live television from the payload bay cameras as the crew is asleep. Flight controllers here are remotely operating those. Currently, we're in blockage with the KU band antenna, where it's blocked by the orbiter's structure and cannot communicate with the tracking and data relay satellite, and thus we have no TV. However, we are expecting more television toward the latter part of this orbit, and the integrated communications officer here in Mission Control will look again for thunderstorms near the coast of Africa as this orbit crosses the coast of Africa. This is Mission Control Houston. We're again receiving television from Discovery's payload bay cameras as it crosses over South America. Discovery's cameras are picking up lightning flashes from storms over the Brazilian rainforest at present, very small flashes. This is Mission Control Houston. We're continuing to get television from Discovery's payload bay cameras as it is over the Atlantic Ocean. This picture, you can faintly see the rim of the Earth, the limb, the horizon at night, with one star apparent at the very bottom of the picture. We are expecting more television of lightning activity as Discovery crosses the African coast here momentarily. At 2 days, 13 hours mission elapsed time, this is Mission Control Houston.
And this is Hubble Telescope Control Greenbelt. The orbital verification team here in the Space Telescope Operations Control Center is proceeding with a number of activation activities required throughout the evening to clear the way for the aperture door opening of the Hubble Space Telescope. Currently, that door opening is scheduled between 6:30 and 7 a.m. Eastern Daylight Time tomorrow morning. That activity had been scheduled to occur at approximately noon Eastern Time tomorrow, but was moved forward earlier today after replanners had determined that a number of the activation and checkout procedures could be delayed until a little later in the orbital verification process. So far this evening, the control team has completed a number of sequences and verifications of the pointing control system, as well as other activities that are required prior to that aperture door opening. These activities will continue through the night up until tomorrow morning. At this time, the earlier problems with the telemetry through the high gain and low gain antennas has been completely cleared up. Not working any problems at all at this time, either here in the control center or at the Huntsville Operations Support Center at the Marshall Space Flight Center in Alabama. All continuing to go well, and looking forward to opening of the aperture door tomorrow morning. At mission elapsed time, 2 days, 13 hours, 2 minutes. This is Hubble Telescope Control Greenbelt.
And here in Mission Control, we are watching television from Discovery as it crosses the African coast, picking up lightning flashes from a band of thunderstorms along that coast. This is Mission Control Houston. We've regained television from Discovery's Payload Bay cameras as it approaches sunrise over Egypt in the Middle East on orbit 39. Tail of Discovery is visible in the lower right corner of the picture. Also lightning flashes over Egypt. This is Mission Control Houston. We're receiving live television from a camera mounted in the forward left-hand corner of Discovery's Payload Bay, being remotely operated by flight controllers on the ground. Of dawn breaking over the Persian Gulf on orbit 39. Discovery is currently at 330 nautical miles altitude, the high point in its orbit. This is Mission Control Houston. We've had loss of communications with Discovery as it passes out of range of the Eastern Tracking Satellite. We'll continue to receive intermittent television from Discovery throughout the night. However, it should be spotty due to demands from Hubble Space Telescope for use of the tracking and data relay satellite system. Our next television event will be a replay of Flight Day 3 activities. That's scheduled to occur at 9 p.m. Central Daylight Time, or 2 days, 13 hours, 26 minutes mission elapsed time. This is Mission Control Houston. That concludes our replay of Flight Day 3 activities on STS-31. Here in Mission Control, flight controllers are busy putting together the morning messages for Discovery. On board the spacecraft, the crew is at their midnight. They're in the halfway point of an 8-hour sleep period. It's been a very quiet night. Most of the work going on here in the control center is on options in case there is a problem with Hubble Space Telescope, although everything is fine at the moment. Options for Discovery's plans to return to the telescope if need be. As it stands, though, tomorrow should proceed as planned without any major changes. We are expecting more live television from Discovery's Payload Bay cameras tonight, although most of that television will occur during the last half of the next 2 orbits, once Discovery has acquired the Eastern Tracking and Data Relay Satellite. And much of that television will be at night on the dark side of the Earth. We aren't receiving television through the Western Tracking and Data Relay Satellite for the next 2 orbits due to Hubble Space Telescope using the KU band portion of that satellite for their checkout and verification activities. At 2 days, 14 hours, 2 minutes mission elapsed time, this is Mission Control, Houston.
This is Hubble Telescope Control Greenbelt at 2 days, 14 hours, 7 minutes mission elapsed time. The next television event scheduled was the Space Telescope Operations Control Center change of shift briefing with second shift Director of Orbital Verification, Ron Schlagheck. That briefing scheduled to originate from the Goddard Space Flight Center at 11:30 p.m. Central Time has been canceled. Again, the second shift Director of Orbital Verification briefing with Ron Schlagheck has been canceled. This is Hubble Telescope Control Greenbelt. This is Hubble Telescope Control Greenbelt at 2 days, 14 hours, 25 minutes mission elapsed time. The very busy and productive evening for the Shift 2 Orbital Verification Team continues in the Space Telescope Operation Control Center. Most recently, the team has successfully completed the powering up of the fine guidance electronics on the spacecraft, and has also just recently verified that the science computer is capable of receiving commands, and in fact has verified the science instrument computer software. Have just gone through or are currently in a short period where we have lost our signal and command capability. This is a planned loss of signal. When we return to commanding, we will be further aligning the three fixed head star trackers to one another, as well as to the onboard flight computer. All going well here in the control center as we continue through the activation procedures leading up to aperture door opening of the Space Telescope tomorrow between 6:30 and 7 a.m. Eastern Time. That, of course, a major activity in the orbital verification of the Space Telescope, the opening of that door to admit the first light from space into the Hubble Space Telescope mirrors. At 2 days, 14 hours, 27 minutes mission elapsed time, this is Hubble Telescope Control Greenbelt.
This is Mission Control Houston. We're now receiving live television from Discovery. As it crosses off the east coast of South America over the Atlantic Ocean. The Earth's limb can be seen at the bottom of the picture, and several stars above that. Also lights present on the Earth's surface. And here in the control center, we're still receiving television from Discovery's payload bay camera, a black and white camera in Discovery's payload bay. Lightning flashes can be seen near the Earth's horizon as stars set in the atmosphere. Discovery currently midway across the Atlantic Ocean, headed toward the west coast of Africa on orbit 40. This is Mission Control Houston. We're now watching lightning flashes from Discovery's payload bay cameras as it crosses the coast of Africa. Also lights from cities in Africa. Discovery's current altitude is 330 nautical miles. And Discovery is now moving just a few minutes away from sunrise, the third sunrise of the night for Discovery. And this Mission Control Houston, we have our live television picture back from Discovery now of sunrise over northern Africa. And this view shows the shuttle's remote manipulator system, or robot arm, the one used to deploy Hubble Space Telescope and now berthed back on the side of the payload bay. This view is from camera D in Discovery's payload bay at the forward right-hand corner of the bay, forward left-hand corner of the bay. Hubble Space Telescope is currently about 48 nautical miles in front of Discovery, and Discovery is closing on the telescope at this time at about 1.6 nautical miles per orbit. In the middle of the robot arm is the elbow camera, a remote-controlled camera mounted on the arm's elbow to assist in grappling procedures. And this picture is now from the elbow camera of the remote manipulator system, as the integrated communications officer here in the control center switched cameras with the limb of the Earth and sunrise in the upper left corner. In this view, looking over the side of Discovery's payload bay toward the payload bay door, the open payload bay door. With the camera pointing almost straight down. And this view of the Earth looking across the Red Sea. Discovery currently over Egypt. Now switched back to the forward left-hand corner camera in the payload bay.
This is Hubble Telescope Control Greenbelt at 2 days, 15 hours, 7 minutes mission elapsed time. The next scheduled television event was to be the change of shift briefing with off-going Director of Orbital Verification, Ron Schlagheck. That briefing was to be conducted at 11:30 Central Time. That briefing has been canceled. In the change of shift briefing from Goddard Space Flight Center with the Space Telescope Operation Control Center Director of Orbital Verification, Ron Schlagheck, that briefing canceled. All activities continuing to go well here as we proceed towards tomorrow's opening of the aperture door of the Hubble Space Telescope sometime between 6:30 and 7 a.m. Eastern Daylight Time. That obviously a major event in the orbital verification of the Hubble Space Telescope as the aperture door is opened and the first light from space comes into that telescope to the Hubble Space Telescope mirrors. Very busy night here in the Space Telescope Operations Control Center as a number of procedures are being completed in preparation for that aperture door opening tomorrow morning. All going well at this time at 2 days, 15 hours, 8 minutes mission elapsed time. This is Hubble Telescope Control Greenbelt.
This is Mission Control Houston at 2 days, 15 hours, 44 minutes mission elapsed time. Discovery now completing its 40th orbit. We're about 2¼ hours away from awakening the crew. That event will occur at 1:34 a.m. Central Daylight Time this morning. It's been a very quiet night in Mission Control. Flight Control has been monitoring the systems on board and have seen everything function normally throughout the night. Most work here is concentrated on putting together the morning mail for the spacecraft and also refining plans for possible rendezvous with Hubble Space Telescope if that should become necessary. Discovery is currently a little bit more than 40 nautical miles behind Hubble Space Telescope, catching up to the telescope at the rate of about 1.6 nautical miles per orbit. We have received some live television from Discovery overnight from remote-controlled cameras in the payload bay. However, we don't expect any more television throughout this orbit until end of orbit 41. Among the activities planned for Flight Day 4 for the crew tomorrow are photography with the IMAX cameras, both the in-cabin camera and the cargo bay IMAX camera. Those are shots of various areas of the Earth, including the Caribbean and the southern tip of Africa and the Brazilian rainforest. And also, if all goes well with Hubble Space Telescope verification and checkout tomorrow, the crew will repressurize the cabin to 14.7 pounds per square inch. Currently, the cabin pressure is at 10.2 psi. Crew will also perform a check of the protein crystal growth experiment on board. Among the activities conducted by the crew on Flight Day 3 was a gravity gradient detailed test objective. That objective used a gravity stabilized position that Discovery stayed in for about 7.5 hours. And the guidance, navigation, and control systems engineer here in Mission Control gave a short status of that to the flight control team earlier this evening. Everything went very well with the detailed test objective. As was expected, the gravity stabilized attitude was really performed better at a higher altitude, this being the highest altitude shuttle flight ever, than it has at 160 nautical mile altitudes. That mainly due to the fact that there's less interference with the spacecraft from the atmosphere and less alterations in its position, less forces acting upon it. At 2 days, 15 hours, 49 minutes mission elapsed time, this is Mission Control.
This is Hubble Telescope Control in Greenbelt. We're at MET 2 days, 15 hours, and 54 minutes. A quick summary of activities over the last 3 to 5 hours at the Space Telescope Operations Control Center. Currently, operators at the stock here are in the process of wrapping up sequence 54. Sequence 54 is a sequence to align the 3 fixed head star trackers to themselves and to the onboard flight computers. This sequence is scheduled to last, it's a rather lengthy sequence, and it's scheduled to last about 230 minutes. It started at MET 2 days, 15 hours, and 16 minutes, so we're only about 45 minutes into that sequence. We have quite a bit of time left on that sequence. At MET 2 days, 11 hours, operators here at the stock completed sequence 48. That was a sequence to verify data interfaces between the onboard flight computer and the optical telescope assembly. They completed sequence 49 at MET 2 days and 13 hours, roughly 3 hours ago. Sequence 49 was to turn on the fine guidance electronics. Operators at the stock began sequence 53 at MET 2 days and 14 hours. That was a sequence that lasted about 20 minutes. And 53 was a sequence to initialize the science instrument computer software and check it out. So currently we're in 54, and again that will last 250 minutes. This is Hubble Telescope Control in Greenbelt, Maryland. quick status on Hubble Space Telescope. Operators here at the Space Telescope Operation Control Center are proceeding through sequence 54. Sequence 54 is an alignment of the 3 fixed-head star trackers to themselves. They align and check each other out. And they also check their alignment to the onboard flight computer. There's been a change of shift here at the stock, and the new shift is on now, and will be on for anywhere from the next 8 to 12 hours. And the telescope has just finished a routine slew that started at 1:05 Eastern Daylight Time and completed at 1:17. All is well with the telescope. All systems are nominal. There are no problems to report on the Space Telescope. Checkout is going as per the scheduled timeline. In general, all seems to be going very well with the Hubble Space Telescope at this point. We're at MET, 2 days, 16 hours, and 46 minutes. This is Hubble Telescope Control.
This is Mission Control Houston. We've lost communications with Discovery as it passed out of range of the eastern tracking satellite. This will be a much longer than normal loss of communications. Will last about 23 minutes. That's due to acquiring the western tracking satellite 17 minutes later than would be normal. Those extra 17 minutes of without communications are due to Hubble Space Telescope support by that satellite. Everything on board the spacecraft has been functioning well all night long. It's been a very quiet night here in Mission Control. Flight controllers are wrapping up the details on morning messages to Discovery. We're about 1 hour, 8 minutes away from awakening the crew. That's an event that will occur at 1:34 a.m. Central Daylight Time. At 2 days, 16 hours, 51 minutes mission elapsed time, this is Mission Control Houston. This is Mission Control Houston. Our next television event will be awakening of the STS-31 crew aboard Discovery, and that will occur at 1:34 a.m. Central Daylight Time, or 2 days, 18 hours mission elapsed time. Here in the control center, we've again acquired communications with Discovery. Flight controllers are getting ready to send a final approval on the morning messages and get them ready to be transmitted to the spacecraft. We're about 45 minutes from awakening the crew. This is Mission Control Houston. We're again receiving live television from the cameras in Discovery's payload bay. This is Mission Control Houston again. We're watching live television from Discovery. The forward left-hand camera on the payload bay. Discovery is now moving into evening and the dark side of the Earth on orbit 42 as the sun sets on the robot arm. And the limb of the Earth can be seen in the dark about halfway up the screen. Flight controllers here are now reviewing the final message that will be sent to the crew prior to their awakening. That message is an outline of their activities for Flight Day 4. Most of those activities will occur as planned prior to the flight. One additional test objective that will be accomplished tomorrow will be a repeat of the gravity gradient DTO done today, or done yesterday on Flight Day 3. That puts the orbiter in a gravity-stabilized attitude for several hours to test that attitude as a method of conserving RCS fuel. On flight day 3, it worked very well, and at a higher altitude worked better than it does on normal altitude shuttle flights. Much of tomorrow will be a wait and see day for the crew as they wait on Hubble Space Telescope to test the opening of its aperture door, the door that covers the lens. Once that test is performed and the door is confirmed to be working properly, Discovery will no longer be on call for a possible rendezvous with the telescope to work out any problems. And planning shift flight director has just given the go to uplink all the messages for the morning to Discovery. This is Mission Control Houston. Our next television event will be crew wake up for STS-31 on flight day 4. That will occur at 1:34 a.m. Central Daylight Time, or 2 days, 18 hours mission elapsed time, about 9.5 minutes from now.
Good morning, Discovery. For Max Q's keyboard, that's the way that song should really be done. Your next practice is Sunday evening in the gym. Don't be late. The KU is in blockage right now. We'll send the rest of your morning mail in a few minutes when it comes out. We have no pressing messages for you this morning, so we'll give you time to get ready for the day.
Okay, thanks, KT. I thought that was recorded at our last practice. That sounds just like the way we do it.
Max Q is auditioning a new keyboard. You better get back and protect your position.
Okay. Bruce says we got 6 tag sheets already this morning.
Yeah, we sent 6. We have, I think, 11 more to go when the KU comes out of blockage.
Okay. Well, if you get us home on Sunday, I'll go to practice.
That's a deal. We're counting on it.
This is Mission Control Houston at 2 days, 18 hours, 4 minutes mission elapsed time on board Discovery. The crew's awake. They were awakened with the song Kokomo as performed by the Beach Boys. And spacecraft communicator Kathy Thornton spoke to Mission Specialist Steve Hawley, referring to the astronaut band Max Q, for which Steve Hawley plays keyboards. And Max Q has been practicing that song. And Mission Specialist Steve Hawley is and Capcom Kathy Thornton referred to the fact that Max Q may be looking for a new keyboardist since Hawley's has been absent.
This is Hubble Telescope Control in Greenbelt, Maryland. We're at MET 2 days, 18 hours, and 8 minutes. Hubble Space Telescope is going through a tape recorder dump at this time. It'll be finished here very shortly. After that, operators here at the Space Telescope Operations Control Center will put the telescope through a memory dump and go through some command rate changes. The memory dump of the general purpose computer, the DF224 on the telescope, will happen during the next TDRS contact. There are several slews that are scheduled during the next couple of sequences. These slews are some are slews in the telescope, some are slews in the solar arrays. And reports now that the memory dump is beginning and the tape recorder dump has been completed. Several milestones coming up in the next couple of hours. As best we can tell, at MET, 2 days, 18 hours, and 5 minutes, the latches that hold the aperture door in place will be relaxed, and at MET 2 days and 18 hours and 58 minutes, the door, which is slightly ajar right now, will be closed in preparation for a final opening. The slews for the telescope and the solar arrays are slews that are commanded into sequences, and they are time activated by the computer, and they're not necessarily commanded from the ground. All of these activities leading up to opening of the aperture door this morning, and we expect that to happen probably early in the morning, sometime before 7:30. We're at MET 2 days, 18 hours, and 10 minutes. This is Hubble Telescope Control in Greenbelt.
This is Mission Control Houston. We're now receiving unscheduled live television from camera in Discovery's payload bay. This is from the forward left-hand camera. The picture is as Discovery crosses the eastern coast of Africa. Discovery is currently approaching the high point of its orbit. It's in a 333 nautical mile by 329 nautical mile high orbit. Right now it is at 333 nautical miles altitude, and that makes this television the highest television ever shot from a space shuttle. The last time that a NASA manned spacecraft really had an opportunity to photograph the Earth with still photography or with television or film from this altitude was on Gemini 11 in September 1966. Gemini 11 was in a 160 nautical mile by 780 nautical mile orbit, elliptical orbit for 2 orbits, and during that time it passed over this portion of the Earth at about 330 nautical miles. These views are of the Sahara Desert as Discovery passes over it on orbit 42.
Discovery Houston, we'd like for you to start the maneuver for the dump at 1825, please.
Okay, Kathy, we'll put it in work.
And Discovery Houston, I have a switch throw on panel R2 as long as you're up there.
Go ahead.
Hydraulic circ pump power 2 to main Charlie. We'd like to get that load off of fuel cell 2.
You mean R12? Or A12?
That's for my mistake. A12, hydraulic circ pump power 2 to main Charlie. My fault.
Okay, we got it coming.
This is Mission Control Houston. We're still receiving live television from Discovery as it passes over Egypt on orbit 42, nearing the coast of the Red Sea with a cloud bank over the Sahara Desert.
Discovery Houston, Houston, if you have someone up on the flight deck, we like the stars that are in the table now. You can align to those and cancel the IMU maneuver.
Okay, KT, we'll do that.
And now this view shows the coast of...
And Kathy, we just got to your tags up, flight plan changes. Understand you want flash evap feed line heater A back on 2 for a while?
Yeah, that's affirmed. We do. We don't believe that it was an anomaly. There was a hot slug of water going through at the time because the heater and the temperature sensor are not located in the same place. So we think that that heater is okay, and we'd like to run on it today.
Okay, we'll do that.
And Discovery is now moving out over the Indian Ocean with this view of the coast of Africa.
Discovery Houston, we're 2 minutes to LOS. Pick you up on the other side at 1840.
Okay, we copy, Kathy.
This is Mission Control Houston. We've lost communications with Discovery as it passes out of range of the eastern satellite. Just prior to losing communications with the spacecraft, the flight activities officer here in Mission Control confirmed that one complete set of all the morning messages was on board. The crew was awakened this morning to the song Kokomo as performed by the Beach Boys. An exchange between spacecraft communicator Kathy Thornton and mission specialist Steve Hawley followed. That Steve Hawley is a member of an astronaut band entitled Max Q, and that band has been working on that song. Spacecraft communicator Kathy Thornton said that she played it for wake-up music to show how it should be played. At 2 days, 18 hours, 35 minutes mission elapse time, this is Mission Control.
Discovery Houston, we're back with you on the west. Discovery Houston, we're with you on the west.
Okay, Kathy, we copy. And do you have quantities for the dump, water dump?
Stand by one. Discovery Houston, we'd like for you to dump tank Bravo to 0%.
Okay, tank Bravo to 0.
That's affirmed.
Discovery Houston.
Go ahead.
Wait a minute. I must be a former Capcom. I just said that backwards.
That's okay. I'll be up there if you want to change.
That's a fair trade, KP. A word for the IMAX folks on ICBC, and it will be a little cryptic, but Tony Myers will know what I mean. Would you tell her the Great Himalayas never looked greater than they did last night, and I hope she agrees. About 35 seconds.
Okay, we'll pass that along. Thanks. And if you want to be Houston, I'll be Discovery
one
anytime.
other thing for her, KT, the footage indicator currently is reading 2125 for ICBC.
2125. Thank you. And if you want to be Houston, I'll be Discovery any day.
No, I don't like that deal.
Houston, Discovery.
Go ahead, Discovery.
Are you guys going to send us up a couple more copies of the flight plan page changes?
Stand by one. That's affirmative. We have 2 more copies on the way.
Thanks a lot. Makes life a lot easier.
Yeah, I bet it does.
Another question, Houston.
Okay, we're listening.
You've been having us do the cable positioning in the morning. You still want that this morning?
Discovery Houston, we have some more tags messages to send you, but we are in KU blockage right now. If you'd like to do the cable positioning now, you have a go for that. Or you can wait till after you get your final messages.
Okay, we'll do it right now then.
Okay, we copy that. Discovery Houston, we'd like for you to not purge fuel cell 2, and you can do an auto purge on fuel cells 1 and 3.
Okay, we'll do auto on 1 and 3 and leave out 2.
That's affirmative.
This is Mission Control Houston. Our next television event, as previously scheduled, was a change of shift briefing with Lee Briscoe, off-going planning shift flight director, and that has been canceled. Again, the change of shift briefing with planning shift flight director Lee Briscoe has been canceled.
Discovery Houston, your planning team is signing off. We're turning you over to Orbit 1. We'll watch over you again tonight and talk to you tomorrow morning.
Okay, thank you, Kathy. We appreciate all your work, and we'll see you again in the morning.
Okay, y'all have fun.
We will.
Discovery Houston.
Houston Discovery.
This is Hubble Telescope Control Greenbelt at MET. 2 days, 19 hours, and 10 minutes. Operators here at the Space Telescope Operation Control Center are in the process of sending commands up to the telescope to...
Discovery Houston.
Good morning, Troy.
Good morning, Lauren. We lost you for a while there. We're working on getting you up a couple extra copies of the flight plan. You're going to be in blockage for 2 hours now, unless we make a special maneuver.
The last transmission was a little garbled. Can you say again, Troy?
We're going to be in TDRS blockage for the next 2 hours, so we cannot get you up the extra copies of the flight plan, unless we do a special orbiter maneuver.
Okay, we copy. And you guys are getting up pretty early these days, aren't you?
Yes, this orbit is turning into a graveyard shift. It's about 2:45 down here.
Roger that.
Getting close to where you all were.